Hello there, and welcome to The Cosmographer. In 1964, a Soviet astronomer named Nikolai Kardashev drew a ladder with only 3 rungs, and every rung above the first describes a civilization so far beyond us that we would struggle to tell it apart from a god. Tonight, we climb the whole ladder, all 9 rungs of it, from a civilization that harnesses the entire energy of its home planet, to one that wraps its star in a swarm of collectors, to one that industrializes 100,000 galaxies and still leaves the night sky dark. We will pass a tier that could reach in and rewrite the laws of physics, a tier indistinguishable from a deity, and, at the very top, a final rung so absolute that the ladder can climb no higher. Not one of these is pure fiction. Every rung is built on real physics. Get comfortable and settle in. If falling asleep to the far edges of what the universe may permit is your idea of a good night, a quiet like and subscribe genuinely helps this channel reach more curious minds like you. Because by the end of this climb, you will understand why the emptiness of the night sky may be the most unsettling discovery in all of astronomy. Let's begin at the bottom, on the first rung, the one with our own name on it. Part 1. Type 1. The Planetary Civilization. The universe does not rank its civilizations by their art, or their kindness, or the stories they tell about themselves. If it ranks them at all, it ranks them by a single measure, and that measure is energy. How much of it a civilization can gather, how much it can hold, how much it can turn into work and light and the shaping of worlds. That one number is the ladder we are going to climb tonight, one rung at a time, from the very bottom, where we happen to be standing, to a ceiling so far above us that the laws of physics themselves begin to soften and give way. It is a long climb. 3 hours is not too much time to give it. The ladder has a name, and it has a maker. In 1964, a Soviet astronomer named Nikolai Kardashev sat with a practical problem. If another civilization were sending us a radio signal from somewhere out in the galaxy, how strong might that signal be? And therefore, how far away could we still hear it? To answer that, he needed a way to sort civilizations by their power. Not their weapons, not their wisdom, but their raw command of energy. And so he drew 3 rungs. A Type 1 civilization, he said, could harness all the energy available on its home planet. A Type 2 could harness the entire output of its star. A Type 3 could command the energy of an entire galaxy, the combined fire of hundreds of billions of suns. 3 rungs, each one roughly 100 billion times more powerful than the last. He thought 3 rungs would be enough for anything alive. He was, as we will see, being modest. Because in the 60 years since, other minds have taken his ladder and extended it far past the galaxy, past the universe, past the point where energy is even the right thing to measure, all the way up to a rung that is indistinguishable from a god, and one rung beyond even that. Tonight we climb every one of them. We will start on real ground, with real numbers and real search programs pointed at the real sky. And as we rise, the ground will thin, the way the air thins on a mountain, until we are standing in pure thought experiment, looking down. There is a word in the title of this list, and the word is Terrify. It is worth being honest about that word before we begin, because the fear on this ladder is not the fear of monsters. Nothing on this list is coming to hurt you. The unease that these ideas produce in the scientists who take them seriously is a quieter thing, and it comes from 3 directions at once. The first is arithmetic. When you actually place our own civilization on this scale, we do not come out looking impressive. We do not even come out on the first rung. The second is silence. If the higher rungs are truly possible, the sky should be loud with the evidence of them, and instead it is strangely, stubbornly quiet. And the third is a question that sits underneath the whole climb and never quite goes away, which is whether the top of this ladder has already been reached by someone else, somewhere, and whether we would have any way of knowing if it had. Hold those three things loosely as we go. Arithmetic, silence, and the question underneath. They are the real reason this list unsettles people. So let us start at the bottom. Let us start with the rung that has our own name on it. Let us start with Type I. A Type I civilization is a planetary civilization. It has learned to capture and use all of the energy available to it on its home world. Every bit of sunlight that falls on the planet, it can collect. Every source of heat and motion the planet offers, from the wind to the tides to the fire in its own molten interior, it can turn to purpose. Nothing is wasted, because a true Type I has closed the gap between the energy that arrives and the energy it can use. On the number line that Kardashev drew and that Carl Sagan later refined, that level of mastery corresponds to a power of very roughly 10 to the 16th watts. 10,000 trillion watts. Always, without pause. That number means very little in the abstract, so let us put ourselves next to it. Humanity today, all 8 billion of us, every power plant and every engine and every glowing screen combined, draws on the order of 18 to 20 terawatts. That is 18 to 20,000 billion watts, which sounds enormous, and in human terms it is. But set it against the Type I threshold, and it is roughly 1,000 times too small. We are using something like 1,000th of what our own planet actually offers. The sunlight that strikes the Earth in a single hour carries more energy than our entire civilization uses in a year, and almost all of it simply arrives, warms the ground, and radiates back out into the dark, untouched by us. Carl Sagan gave us a way to say exactly how far short we fall. He took Kardashev's 3 rungs and turned them into a smooth slope, a formula that lets you place any civilization on the scale, using nothing but the number of watts it commands. Run our own power consumption through Sagan's formula, and a single number comes out the other side. 0.73. That is where we are tonight. Not Type I, not even close to Type I. We are a Type 0 civilization, sitting at about 0.73 on the way to the first rung, a species that has not yet learned to use the full energy of the one planet it has. Hold on to that number. 0.73. We are going to meet it again, much later and much higher, when we look back down the ladder from a place near the top. For now, let it just sit with you, because almost everything else on this list towers over it. Every civilization we're about to describe is, by definition, more powerful than a planetary one, and we have not even managed to become planetary yet. How long until we do? The physicist Michio Kaku offered an estimate in his 2011 book, Physics of the Future, and it is a useful anchor. If our civilization keeps increasing its energy use by something like 3% a year, roughly the pace of ordinary economic growth, then we reach true Type I status in about 100 to 200 years. A century or two. Within that same framework, Type II, the mastery of an entire star, would take a few thousand years, and Type III, the mastery of a galaxy, somewhere between 100,000 and 1,000,000 years. Those are not promises. They are what the arithmetic of steady growth suggests, and the arithmetic assumes we survive long enough to keep growing, which is a very large assumption. Because here is the first uncomfortable thing about the very first rung. Reaching it is dangerous. To become a Type I civilization, you have to command planetary energy, and you have to do it on a planet whose climate and chemistry are delicately balanced by exactly the energy flows you are learning to seize. A species climbing toward Type 1 is a species with enough power to remake its own world, and not necessarily enough wisdom to do it gently. Some scientists talk about this as a filter, a narrow and hazardous passage that a civilization has to survive on its way up. The moment you can reshape your planet is also the moment you can wreck it. We are inside that passage right now. We do not know how many civilizations make it through. We only know that we have not finished the crossing. There is something else worth noticing about Kardashev's scale before we climb any higher, and it is part of why the scale can feel cold. The ladder measures capability, and only capability. It says nothing about whether a civilization is happy, or just, or kind. A cruel civilization and a gentle one earn the exact same rank if they command the same energy. A planet-spanning tyranny and a planet-spanning paradise sit on the same rung. The scale does not care. It is a measure of power, drawn by an astronomer who wanted to know how loud a signal might be, and it carries none of the things we usually mean when we call a people advanced. That silence about everything except power is, quietly, one of the more unsettling features of the whole idea. We are about to spend 3 hours ranking civilizations, and at no point will the ranking ask whether any of them were good. What would it actually be like to stand on a finished Type 1 world? The sunlight would not fall unused. Every surface that could gather energy would gather it, so the planet from orbit might look subtly altered. Its deserts and its oceans working, its weather no longer purely wild. In Michio Kaku's description, a Type 1 civilization does not merely collect its planet's energy, it steers its planet's systems, because those systems are simply energy in motion. The weather becomes something that can be calmed. The tremors of the crust become something that can be managed. The storms that we currently endure become, on a Type I world, flows to be redirected. It is not magic. It is the ordinary consequence of a civilization that finally commands the same power its planet does, and has learned to hold that power without dropping it. Picture it for a moment, that finished world, from a slow orbit above it. The night side is not dark the way ours is dark, scattered with the accidental glow of cities that waste half their light on the clouds. It is lit with intention, every joule accounted for, the whole planet, a single working system that has stopped losing energy it did not mean to lose. The storms that would once have flattened coastlines are felt in advance and eased before they gather. The tremors that would once have leveled cities are bled off gently, a little at a time, before they can build. Nothing about this world is wild in the way our world is still wild, and nothing about it is loud. It is a planet whose civilization finally commands the same power the planet itself commands, and has learned to hold that power the way you hold something fragile, without dropping it, without crushing it. That is a Type 1 world. Calm, lit, deliberate, and entirely in control of the single sphere it stands on. We are not there. We are at 0.73 in the middle of the crossing, with the tools to change our world and no guarantee that we will change it well. That is the rung with our name on it, the nearest one, the one we can almost touch. And it is only the first. What would actually carry us across the gap to Type 1, in concrete terms, is worth naming, because it is not mysterious. 2 technologies would most likely do it. The first is the full harvesting of sunlight, at a scale far beyond today's scattered panels, whether spread across the deserts of the planet or gathered in orbit where the sun never sets. The second is nuclear fusion, the reaction that powers the stars, which we have been trying to tame on the ground for decades and have not yet made practical, but which, if mastered, would let a civilization build small suns of its own and stop depending on the buried remains of ancient life. A true Type 1 civilization has almost certainly solved fusion. It has stopped burning its inheritance and started running on the same reaction that lights the sky. It is worth adding that our own place on the scale is a recent arrival. For nearly all of human history, we sat far below 0.7. Our energy user rounding error against the planet's budget. Only with the industrial age, only in the last 2 centuries, did we climb the steep part of the curve and reach the neighborhood of 0.73, where we now sit. On the scale of a species that might take a century or 2 more to reach the first rung, we crossed most of the distance to it in a geological blink, which is either a reason for hope or a reason for worry, depending on whether the same speed that lifted us can also be steadied. It is worth knowing a little about the man who drew this ladder, because his reasons were not the reasons most people assume. Nikolai Kardashev was born in 1932 in Moscow, and he grew up to become one of the Soviet Union's leading radio astronomers. He was not a dreamer spinning fantasies about alien empires. He was a working scientist who studied quasars and the distant radio sources of the universe, and the ladder came to him as a practical tool for a practical problem. In 1963, there had been a brief flurry of excitement over a quasar called CTA 102, when a Soviet astronomer suggested its signal might be artificial. It was not. It was a natural object. But the episode sharpened a real question in Kardashev's mind. If a genuine signal from another civilization ever did arrive, how would we judge what kind of civilization had sent it? His answer was to sort them by power, and the scale was born not from science fiction, but from the sober business of trying to hear across the galaxy. The scale measures a single thing, and it measures it across the entire history of a species. To feel where we sit on it, walk for a moment through the story of our own energy. For most of the time there have been humans. Our entire power supply was the human body itself, a steady output of roughly 100 watts per person, the warmth of muscle and the labor of hands. Then came fire, which let us release the stored energy of wood and cooked our food and doubled the reach of a single body. Then came agriculture, which harnessed sunlight through crops and through the animals we set to work. Then, only a few centuries ago, came the machines, the steam engine, and the coal seam and the oil field, and our energy use climbed a curve so steep that in a handful of generations we went from candles to a civilization that lights the night side of the planet brightly enough to see from space. All of that history, every fire and field and furnace, adds up to the 18 to 20 terawatts we command today. And it places us at 0.73. To finish the climb to a true Type 1, consider what the planet actually offers. The sunlight striking the top of Earth's atmosphere amounts to something like 170,000 terawatts, a number so far above our 18 that it is almost comical. We are bathed every second in roughly 10,000 times the energy our whole civilization uses, and we capture a sliver of it. A genuine Type 1 civilization would close that gap. It would capture sunlight at planetary scale, and it would very likely have mastered nuclear fusion, the same reaction that powers the stars, learning to build small suns of its own on the ground. It might ring its world in orbital collectors, or carpet its deserts, or do things we have not thought of. What defines the rung is not the method, but the result. Nothing the planet offers goes unused. The physicist Michio Kaku has been blunt about which part of this climb is the most dangerous, and it is not any of the higher rungs. It is the one we are on right now, the transition from a Type 0 civilization to a Type 1. A species at this stage has the power of a planet in its hands, but not yet the unity or the wisdom to wield it safely. And it faces every hazard its own growth creates: the destabilized climate, the competition for resources, the weapons that planetary energy makes possible. Kaku has described the passage from 0 to 1 as the moment a civilization is most likely to destroy itself, precisely because it has become powerful faster than it has become wise. Some scientists frame this as part of a larger idea called the Great Filter, some barrier that stops most civilizations from ever rising far, and one of the open and genuinely unsettling questions is whether that filter lies behind us, already past, or ahead of us, still waiting. We do not know. We only know that the sky, when we search it, shows us no one who has plainly made it through. Because a planet, in the end, is a small thing to feed on. A planet catches only the thinnest sliver of the light its star pours out, a few billionths of the whole, while the rest of that light streams off in every direction and is lost to the dark between the stars. A civilization that wanted more, much more, would eventually look up at that streaming, wasted light and ask a simple, greedy, world-changing question. Why should any of it get away? The next rung on this ladder is a civilization that decided the answer was none of it and set out to catch a star. Part 2. Type 2. The Star Harvesters. To catch a star is a strange ambition, and it is worth pausing on how strange it is. A star is not a resource in the way a coal seam or a river is a resource. A star is a continuous, self-sustaining thermonuclear reaction the size of 1,000,000 Earths, pouring light into space in every direction at once, and it has been doing so, in the case of our own sun, for 4.5 billion years, with billions more still to come. A Type 2 civilization is one that has decided to capture that light. Not a portion of it. Not the fraction that falls on a convenient planet. All of it. Every photon the star produces, gathered and put to use, so that essentially none of it escapes unused into the dark. That is the second rung of the ladder, and it represents a jump in power so large that the human mind has no natural handhold for it. Let us try to build one anyway. Kardashev put the energy of a Type 2 civilization at around 4 × 10⁻26 watts. Compare that to the Type 1 threshold of 10⁻16 watts, and you find the second rung sitting roughly 100 billion times above the first. 100 billion. Not 100, not 100,000, but 100 billion times more power than a civilization that already commands its entire planet. The reason for the gap is simple, and it is a matter of geometry. A planet intercepts only the sunlight that happens to strike its disk, a target a few thousand miles across, floating in the enormous sphere of space around the star. Almost all of the star's light misses every planet entirely and streams off into the night. A Type 2 civilization stops that waste. It stands, in effect, all the way around the star and lets nothing slip past. The structure that would do this has a name, and the name has become famous, though the fame has attached itself to a slight misunderstanding. It is called a Dyson sphere. The physicist Freeman Dyson introduced the idea to science in 1960 in a short and now legendary paper in the journal Science, titled Search for Artificial Stellar Sources of Infrared Radiation. Most people, hearing the phrase Dyson sphere, picture a single solid shell, a hollow metal ball with a star trapped at its center, and a civilization living on the inner surface. Dyson himself never meant that. A rigid shell around a star would be unstable, and it would require more material than a planetary system is likely to contain. What Dyson imagined was looser and far more plausible. He imagined a swarm, a cloud of countless separate collectors, each one in its own orbit, each one drinking a little of the starlight, and together, over time, surrounding the star so thoroughly that its light is captured almost in full. Dyson was honest about where the idea came from. He credited the science fiction writer Olaf Stapledon, whose 1937 novel, Star Maker, described exactly such structures ringing the stars of the galaxy. Dyson took a novelist's image and did something a novelist could not. He turned it into a physics problem, with numbers, and then he did the thing that makes him matter to this list. He asked how you would find one. If a civilization out there had already built a swarm around its star, how would we from here ever know? His answer is the beating heart of everything else on this ladder. So let us take it slowly, because it is one of the most elegant ideas in the whole search for other civilizations. Energy, Dyson knew, cannot be destroyed. It can only be moved and transformed. When a Type II civilization captures its star's light and puts that light to work, running its machines, its cities, its computers, whatever a civilization at that scale runs, the energy does not simply vanish once it has been used. It cannot. The laws of thermodynamics forbid it. Used energy has to go somewhere, and where it goes is out, radiated away as low-grade heat. Not the brilliant visible light the star produced, but something cooler and redder, a warmth given off at the far infrared end of the spectrum. This is waste heat. Every engine produces it. Every living body produces it. And a structure that swallowed an entire star's output would produce it on a scale that nothing natural in that size and temperature range could easily match. That is the signature. That is what Dyson told astronomers to look for. Not a shape, not a shadow, but heat. A star that seemed dimmer than it should be in visible light, while glowing far more than it should in the infrared, as though its light were being intercepted, used, and re-emitted as warmth. You cannot hide it. That is the crucial thing, the thing worth carrying with you all the way to the top of this ladder. A civilization can build whatever it likes around its star, in whatever style it prefers, for whatever purpose we cannot guess, but it cannot break the second law of thermodynamics. It cannot use energy without shedding heat. The waste heat is the fingerprint that no amount of advancement can wipe away. Remember that. We will hold it up again at every rung above this one, and at the very top, it will mean something it does not mean yet. Let us stand inside the idea for a moment before we test it against the real sky. Picture yourself on an airless moon circling a world that circles a star being taken apart for its light. Overhead, the star does not rise and set the way ours does. It hangs there, and it flickers. Where there was once a single clean point of fire, there is now a slow lattice of shadows sliding across it. Collectors the size of continents, thousands upon thousands of them, each on its own patient orbit, each passing between you and the light in turn. The star dims by degrees you could almost count on your fingers, a little more captured with every passing structure. And on the near side of each collector, the side that faces you, the side turned away from the star, there is a faint red warmth, like the glow of a coal that has almost gone out. That glow is the used light. That glow is the exhaust. That glow is the heat the builders could not keep, no matter how advanced they were, and it is the only thing in this whole scene that gives them away. The visible star fades. The infrared warmth spreads. Somewhere in that trade, a civilization is at work. Now bring that picture back to Earth, to a real telescope, and a real star, and a real night when the search stopped being theory. The star is catalogued as KIC 8462852. It sits about 1470 light-years from us, in the constellation Cygnus, the Swan. For most of astronomy's history, it was nothing, an unremarkable point among millions. Then came the Kepler Space Telescope, which stared at one patch of sky for years, measuring the brightness of 150,000 stars over and over, watching for the tiny, regular dips that reveal a planet crossing in front of its sun. And the light from this one star did something no one had a ready explanation for. It dipped. But not the way a planet makes a star dip. A planet produces a small, clean, repeating shadow, a fraction of a percent, arriving like clockwork. This star dropped in brightness by enormous amounts, once by around 22%, and it did so irregularly, with no clean period, no clockwork, no pattern anyone could fit. A 22% dip is not a planet. Even a planet the size of Jupiter blocks only about 1% of a star like this. To dim a star by nearly a quarter, you need something enormous and irregular passing in front of it, something that does not belong to the tidy catalogue of things we expected to find. It was not a professional astronomer who first flagged it. It was volunteers. The light curves from Kepler were more than the scientists could examine by eye, so the data had been opened to the public through a project called Planet Hunters, and it was ordinary people, citizen scientists, scrolling through star after star, who marked this one as bizarre. The astronomer Tabetha Boyajian led the team that studied the anomaly in earnest, and the 2015 paper that resulted was informally known by the question the researchers kept asking each other. Where is the flux? Where is the missing light? That question gave the star its nicknames. Tabby's star, after Boyajian. Boyajian's star, more formally. And, unofficially, the what the fuck star, the where's the flux star, a small joke carrying a very large mystery. Then another astronomer, Jason Wright, said the thing out loud that everyone had been circling privately. He noted, carefully and with all the appropriate caution, that the pattern was at least consistent with what you might expect from a partially built megastructure, a swarm still under construction, catching the star's light unevenly as it grew. He did not claim it was aliens. He said it was worth taking seriously as a possibility, precisely because nothing else fit cleanly. And the world, which had been waiting a long time for exactly this sentence, lost its composure. For a while, in the middle of the last decade, one flickering star in the Swan became the most watched point of light in the sky, because it was the first time Dyson's 55-year-old idea had a real address to point at. Consider what that moment actually was, underneath the headlines. In 1960, Freeman Dyson did something quietly radical. He took the existence of star-enclosing civilizations, an idea that belonged to fiction, and he turned it into a testable hypothesis, complete with instructions for the astronomers who would come after him. "Look for the heat," he said. Then, 55 years later, a crowd of volunteers and a careful scientist and a colleague willing to say the unpopular word all took that instruction seriously enough not to look away from something strange. The human moment here is not the megastructure, because there probably is no megastructure. The human moment is the refusal to stop asking where the flux went. That refusal is what the whole search is made of, and it is a very old and very good part of us. So what did the flux turn out to be? The honest answer, arriving over the next few years, was a slow and gentle deflation. By 2018, follow-up observations with NASA's Spitzer and Swift space telescopes together with the Belgian Astrolabe Iris Observatory, had caught the star dimming again, and this time they measured the dimming across different colors of light. A solid structure, a real megastructure, would block every color of light equally. A wall is a wall. It does not care whether the light behind it is blue or red. But this dimming was uneven. It was stronger in ultraviolet light than in infrared, and that difference is the fingerprint not of a wall, but of dust, because fine dust grains scatter short wavelengths more than long ones. The blocker was not a swarm of collectors. It was almost certainly a cloud of fine dust, uneven and slowly circling, dimming the star's colors by different amounts, because that is what dust does, and a megastructure does not. That is how the most famous candidate faded. Not with a disproof shouted from a rooftop, but with a careful measurement of colors that pointed quietly at dust. And it is worth sitting with how that felt, because it is a feeling this whole list will return to. There was relief in it, the ordinary scientific relief of a mystery resolving into known physics. And there was, underneath, a small loneliness, because the sky had offered us its single best candidate for a star being harvested by someone else, and the sky had taken it back. The search did not stop. It never does. More recently, in 2024, a project with the fitting name Hephaistos, after the smith god of the forge, went looking again, this time with modern data. The Hephaistos team combined 3 great sky surveys, the Gaia Star Catalogue, the survey called 2MASS, and the infrared telescope called WISE, and they sifted through roughly 5 million stars, hunting for exactly Dyson's signature, a suspicious excess of infrared warmth. Out of 5 million, they flagged 7 candidates, all of them small, cool red dwarf stars within about 300 parsecs of us, each one showing more mid-infrared glow than a bare star of its kind should. 7 possible partial Dyson swarms. 7 addresses worth a second look. And here the pattern of this rung repeats itself, which is a pattern worth naming, because it is the pattern of the entire real search. Almost as soon as the 7 candidates were announced, other astronomers began finding more ordinary explanations. Follow-up work suggested that at least some of that infrared excess might not come from swarms at all, but from distant, dust-shrouded galaxies lying almost directly behind the red dwarfs, their far-off glow blending with the nearest star's light and faking the signature. Not a structure around a nearby star, but a galaxy far beyond it, lined up by chance. The candidates are not disproven, but they are, at best, uncertain, and the most likely readings are, once again, natural. So where does that leave the second rung? It leaves us with no confirmed Type 2 civilization anywhere, and a track record in which every promising candidate has, so far, dissolved into dust or distance or coincidence when we looked harder. That could be discouraging. But notice what the search is actually built on, because it is the sturdiest idea we have met yet. It is built on Dyson's point about heat. If star harvesters exist, they cannot be invisible. They cannot hide, because they cannot stop shedding waste heat, any more than you can stop your own body from being warm. Which means the sky is a fair test. If they were out there in any number, close enough to see, we would be finding their warmth. And so far, at the scale of a single star, we are not. The absence of the heat is not nothing. The absence of the heat is itself a kind of finding, and it is the first faint note of a silence that is going to grow louder as we climb. There is a reason the second rung matters more to real science than any of the higher ones, and it is worth saying plainly. Of all the civilizations on this entire ladder, the star harvesters are the only kind we have a genuine, ongoing, instrument-ready search for. We cannot look for a Type 4 rearranging galaxies, or a Type 6 editing the constants of nature, or a Type 8 running a simulation, because we have no idea what evidence those would even leave. But a Type 2 is different. A partial Dyson swarm around a nearby star produces a specific, predictable signature, an excess of mid-infrared warmth, and we have telescopes that measure exactly that and catalogues of millions of stars to sift. The second rung is where the ladder touches the ground of real observation, where speculation becomes a survey you can actually run. Everything below it is us. Everything above it is imagination. The star harvesters sit exactly on the boundary, close enough to hunt. That is why the failures of the hunt carry weight rather than disappointment. Each candidate that dissolves into dust is not a dead end. It is a measurement, a small tightening of the answer to the oldest question we have. The nearby stars that might have worn a swarm, checked and found bare, are data. And the running total of that data, so far, is a sky that offers the star harvester's signature nowhere we have looked closely. That result is quiet, and it is real, and it is the first hard evidence in a case that will only deepen as we climb. It is worth being concrete about the engineering, because the concreteness is part of what makes the idea serious rather than merely grand. To build a swarm around a star, you need an enormous quantity of material, and the obvious place to get it is not a habitable planet, but the useless, rocky, and metallic worlds a system throws in for free. A civilization building a Dyson swarm around a sun like ours would most likely take apart a planet like Mercury, a ball of metal and rock close to the star and good for nothing else, and turn it into collectors, one mirror or panel at a time. The collectors themselves need not be heavy. They could be gossamer-thin light sails, so light that the pressure of the starlight itself holds them up against gravity, hovering in place rather than orbiting, a design real physicists have studied and given the name statite, a static satellite balanced on a beam of light. Build enough of them over enough centuries, and the star is gradually enclosed, not by a wall, but by a slowly thickening cloud of intercepted light. The energy at stake is difficult to hold in the mind, so anchor it against ourselves once more. A star like the Sun radiates about 400 trillion watts every second in every direction. Our entire civilization runs on 18 to 20 trillion watts. The gap between those two numbers is not a matter of degree, it is a matter of kind. Capturing even 1,000th of a single ordinary star would give a civilization tens of thousands of times the total energy humanity has ever commanded, and a full Type 2 captures not 1,000th, but essentially all of it. This is why the second rung is where the ladder starts to feel genuinely alien. A Type 2 civilization is not a richer version of us. It is operating on an energy budget so far beyond ours that almost anything the laws of physics permit becomes, for it, merely an engineering choice. The story of Tabby's star has more chapters than its most famous one, and the later chapters are where the science tightened. Beyond the strange dips Kepler caught, one astronomer, Bradley Schaefer, went back through old photographic plates of the sky, some of them more than a century old, and reported that the star appeared to have been slowly, steadily fading across the whole 20th century, a dimming no ordinary star should show. That claim was disputed, defended, and argued over, and it deepened the mystery rather than resolving it. Then, in 2017, the star did the most useful thing it could possibly do. It dimmed again, in real time, while the world was watching. A global network of telescopes, the Las Cumbres Observatory, had been funded to catch exactly this, in part through a crowdfunding campaign backed by thousands of ordinary people who wanted to help solve the puzzle. The dips that year were caught as they happened and given names by the community that had waited for them, names like Elsie and Celeste, and after ancient lost places, Skara Brae and Angkor. Watching a dip unfold live let astronomers measure its colors. And the colors, as we have heard, pointed to dust. That is the shape of Dysonian SETI, and it is worth naming the approach directly because it is different from the search most people picture. When people imagine the search for other civilizations, they usually picture radio telescopes listening for a message, a deliberate signal beamed our way. Dyson's idea launched a second and quieter approach. Do not wait for anyone to call. Look instead for the unavoidable physical evidence of their industry, the waste heat they cannot hide, whether or not they ever intend to be found. A civilization might choose never to transmit, might have no wish to be heard, and still it could not stop its structures from glowing in the infrared. That is the strength of the method. It searches for what a civilization does, not for what it says. And so far, star by star, the infrared sky has offered nothing that survives a second look. Because a single star, in the end, is still a small appetite. One star among the 400 billion in our galaxy. A Type II civilization has solved the problem of one sun. The next rung belongs to a civilization that looked at the whole glittering wheel of the galaxy, hundreds of billions of stars turning together, and was not satisfied with one. Part 3. Type 3. The Galactic Civilization. A galaxy is a difficult thing to hold in the mind, so before we describe a civilization that commands one, let us try to feel the size of the prize. Our own galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. It measures roughly 100,000 light-years across, which means that light itself, the fastest thing there is, needs 100,000 years simply to cross from one edge to the other. Every star in that immense wheel is a potential Type II project, a sun that could in principle be wrapped and harvested. A Type III civilization is one that has done this not once, not to a handful of stars, but across the galaxy, industrializing suns by the hundreds of billions until the combined output of an entire galaxy is under its command. Kardashev put that level of power at around 4 × 10⁻37 watts. Another 100 billion-fold leap above the star-harvesting Type II. We are now 3 rungs up, and each rung has multiplied our starting point by 100 billion, twice over. The numbers have left every human reference behind. There is no gentle way to picture what a galaxy-spanning civilization would be doing, because the honest picture is one of a galaxy being consumed. Not destroyed in fire, but dismantled for use, star by star, system by system. Its light diverted from the empty night into whatever work such a civilization does. Every sun, a furnace. Every furnace tapped. And here the idea that Dyson planted at the previous rung grows into something you can hunt across the whole sky, because the same law that governs one collector governs 100 billion of them. Waste heat. A single Dyson swarm glows warm in the infrared. A galaxy full of them, a galaxy whose starlight is being caught and used and shed as low-grade warmth, would glow warm in the infrared as a whole. It would look wrong. It would look too red, too warm for the number of stars it appeared to contain, because so much of its visible starlight would have been converted into heat. That wrongness is a signature you can search for not one star at a time, but one galaxy at a time, sweeping across the whole observable universe. And that is exactly what a team of astronomers set out to do. In 2015, a survey with a memorable name went hunting for Type III civilizations across the sky. It was called G-hat, which stood for Glimpsing Heat from Alien Technologies, and it was led by the same Jason Wright, who had spoken carefully about Tabby's star. The instrument was NASA's WISE telescope, the Wide Field Infrared Survey Explorer, a spacecraft that had mapped the entire sky in infrared light, precisely the range of wavelengths where waste heat lives. The team went through the WISE data and pulled out roughly 100,000 galaxies, galaxies near enough and clear enough to examine in detail. And for each one, they asked Dyson's question, enlarged to galactic scale. Is this galaxy glowing with more mid-infrared heat than its starlight can explain? Is anyone in there catching the light? The team did the work carefully. They built a formal framework, which they called the agent formalism, to describe exactly what the infrared spectrum of a galaxy hosting a Type 3 civilization should look like, so that they were not guessing, but measuring against a clear prediction. Then they pointed that prediction at 100,000 galaxies and let the data answer. And the answer, when it came, is one of the quietest and most important results in the whole search for other civilizations, precisely because of what it did not find. Out of 100,000 galaxies, not one showed the signature of a civilization harvesting the bulk of its starlight. None of them glowed the way a thoroughly industrialized galaxy should glow. About 50 of the 100,000 were unusual enough in the mid-infrared to deserve a closer look, but even those are almost certainly natural, galaxies busy with furious star formation, wrapped in dust that glows warm on its own, no civilization required. The pilot survey did not find a single convincing galaxy-spanning civilization. It found 100,000 islands of stars, and every one of them, as far as the heat could tell, was running on nothing but ordinary physics. Let us make sure the scale of that silence lands, because it is easy to say 100,000 galaxies and let the number slide past. A single galaxy is 100 billion stars. 100,000 galaxies is 100,000 times that. An accounting of stars with more zeros than the human mind tracks comfortably. Each star, a potential sun to be harvested. Each galaxy, a potential Type 3 empire. The survey looked at all of them, asked each one whether a civilization had lit it up with the warmth of its industry. And the readout came back, across the whole sample, effectively dark. Not a single galaxy warm with the exhaust of a civilization that had taken it over. The heat that cannot be hidden was simply not there. Stand inside that result for a moment, in the immersive way, because the abstraction hides the feeling. Imagine drifting through a spiral arm of a galaxy that a Type 3 civilization is in the middle of harvesting. The arm was once a river of stars, a bright, crowded lane of suns. Now, ahead of you, it is going out. Not exploding, not dying in supernovae, nothing so violent. It is simply dimming, one star at a time, as though someone were walking slowly down the length of the arm, turning off lights, wrapping each sun until its light no longer escapes. The visible sky around you thins and darkens, star by star, and if you had only your eyes, you might think the galaxy was somehow emptying. But lift an infrared eye to the same scene, and the darkness reveals itself as a lie. The whole region burns a dull, even red, the temperature of a warm room, spread smoothly across 10,000 light-years. This is what a Type 3 looks like from the inside. Not a fire, a warmth. A galaxy quietly converted from light into work, its brilliance spent, its heat still leaking gently into a night that has nowhere else to put it. That is the thing G-hat went looking for across 100,000 galaxies. That is the thing it did not find. The honesty of the G-hat result is the part worth admiring. The team did not find aliens, and they did not bury the null result or spin it into a maybe. They published the silence as a finding, which is what good science does. They framed the survey as a pilot study, a proof that the method works, and a first pass rather than a final census. And they were careful to say what the data could and could not rule out. What it can say is a real and bounded statement about the universe. Galaxy-spanning civilizations that reprocess most of their starlight into waste heat are, at the very most, extraordinarily rare in the nearby universe. Not one clear example in 100,000 galaxies. That is not proof that Type 3 civilizations are impossible. It is a hard, measured ceiling on how common they can be, and the ceiling is very, very low. Which leaves us with a question that has 3 possible answers, and every one of them is unsettling in its own way. Either Type 3 civilizations do not exist, because something prevents any civilization from ever climbing this high. Or they exist but are so vanishingly rare that 100,000 galaxies was simply too small a sample to catch one. Or they exist, they are all around us, and they are doing something that does not glow the way our physics insists it must, which would mean our confidence about waste heat, the one law we thought no one could break, is somehow wrong. Choose any of the 3. The first says the ladder has a lethal rung somewhere below the top, a filter that stops everyone. The second says we are profoundly alone in our corner of the cosmos. The third says our deepest law has a loophole we cannot yet imagine. There is no comfortable option in the set. This is the point in the climb where the ladder changes character, and it is worth marking the change clearly. Up to now, this has been a list about power, about the thrilling arithmetic of civilizations that grow to command stars and galaxies. But standing here at the 3rd rung, looking out at 100,000 dark galaxies, the list quietly becomes something else. It becomes a list about absence. Because if the higher rungs are real, the universe should be showing them to us. A galaxy being harvested is not subtle. It is 100 billion stars worth of warmth that cannot be hidden. And we have looked, with a good instrument and a clear prediction, at 100,000 galaxies, and we have seen none of it. The scientists who take the Kardashev ladder seriously are not kept awake by the thought of a Type 3 civilization arriving to trouble us. They are kept awake by the empty survey. By the fact that the sky, which should be warm with the industry of the advanced, comes back dark. There is a name for the shape of this unease, though we do not need to lean on it too heavily. It is the same silence that the physicist Enrico Fermi gestured at decades before Kardashev, with a simple lunchtime question about where everybody is. If the universe is old and large and friendly to life, and if civilizations tend to grow in power the way ours is growing, then the cosmos should be busy and loud and visibly at work. Instead, it is quiet. Jihad is one modern, rigorous face of that old question. It took Fermi's puzzle and turned it into a measurement, and the measurement came back quiet. Somewhere between the ladder we can imagine and the sky we can see, there is a gap, and no one is certain what lives in that gap. A filter that stops civilizations before they rise. A rarity so extreme that we truly are close to alone. Or a form of advancement so unlike our own that it leaves no heat for us to find. We will return to that last possibility later in the climb, because it turns out to have a serious defender, and it may be the least lonely answer of the 3. Sit for a moment with what the dark survey asks of us, emotionally, because it asks something real. To look at 100,000 galaxies and find them silent is to receive a piece of news about our own place in things, and the news is genuinely ambiguous. It might mean we are early, one of the first civilizations to climb, with an empty cosmos ahead of us, waiting to be filled. It might mean we are rare, perhaps nearly unique, a single lit candle in a room that has stayed dark for reasons we do not understand. It might mean we are missing something, that the advanced are all around us, wearing a disguise our physics cannot yet see through. A careful person can hold all three of those and feel, underneath them, the same quiet vertigo we felt on the first rung when we learned our own rating. The universe is very large, and so far as our best heat-seeking eyes can tell, the heights of the ladder are empty. That emptiness is the true subject of this list, and every rung above here will be haunted by it. It is worth dwelling on what industrializing a galaxy would actually demand, because the logistics alone reveal how immense the third rung is. A galaxy is 100,000 light-years across, which means that even a signal traveling at the speed of light, the absolute limit for anything in our universe, would take 100,000 years just to cross from one side to the other. A civilization coordinating the harvest of hundreds of billions of stars could not do it quickly, could not manage it from a single center, could not even hold a conversation across its own territory without waiting tens of thousands of years for a reply. To become a Type 3 is therefore to become a civilization of cosmic time, one that thinks in spans that dwarf the entire history of our species, patiently spreading from star to star across ages, wrapping suns as it goes. It is not an empire in any sense we would recognize. It is a slow tide of technology rising across a galaxy over millions of years. That cosmic time character is part of what makes the empty survey so striking. If becoming a Type 3 takes millions of years of patient spreading, then any galaxy that started down that road long ago should, by now, be far along it, its stars visibly dimming, its infrared glow rising. The universe has had almost 14 billion years to work with, more than enough time for such civilizations to arise and spread and finish many times over. And yet the sky shows us none in progress and none complete. Either no one starts the climb, or no one survives it, or the whole picture of galaxy-spanning industry is somehow wrong. The cosmic time that a Type 3 requires is time the universe has had in abundance, which only sharpens the question of why the harvest is nowhere to be seen. It is worth understanding how carefully the Jihad team defined what they were hunting, because the care is what turns a wild idea into real science. They did not simply look for galaxies that seemed a little warm. They built a way of describing, in precise terms, how a galaxy would look if some fraction of its starlight were being intercepted by technology and re-emitted as heat, capturing how much of the light was being reprocessed and at what temperature the waste heat would glow. That framework, which they named the Agent Formalism, let them place any galaxy on a scale from completely natural to heavily industrialized, and it let them say clearly what a partial Type 3, one that had harvested, say, half its starlight, should look like to WISE. Only then did they go to the data. The prediction came first, the measurement second. That order is the difference between a search and a hope. The roughly 50 galaxies that did stand out are worth a word too, because their story is the story of the whole search in miniature. They glowed more brightly in the mid-infrared than a simple population of stars would explain, which is exactly the signature a Type 3 would produce. But there is a mundane way for a galaxy to run hot in the infrared, and it is extremely common. Galaxies that are furiously forming new stars wrap themselves in thick clouds of dust, and that dust, warmed by the young stars inside it, glows in precisely the same band where waste heat lives. The universe is full of these dusty, star-forming galaxies, and they are the natural mimics of an alien civilization. wearing the same infrared coat for an entirely ordinary reason. Every one of the 50 candidates is far more likely to be one of these than to be a civilization, and none has shown anything that demands the exotic explanation. The signal we were looking for, and the commonest kind of ordinary galaxy, happen to look nearly the same, and telling them apart is the slow, unfinished work. The VIII team was not the first to think of this, and the history is worth a moment because it shows how long the silence has been accumulating. As early as 1999, the astronomer James Annis looked at a set of nearby galaxies and asked a related question. If a galaxy were being harvested, its visible starlight would go missing, converted to other uses, and the galaxy would appear dimmer in ordinary light than its size and rotation suggested it should be. He looked for galaxies with missing light, and he found none that demanded an artificial explanation. The VIII survey, years later, came at the same silence from the other side. Not the missing visible light, but the waste heat it should turn into, and reached the same result. More recent searches have used radio telescopes, sweeping enormous catalogues of galaxies for the particular signatures a galaxy-spanning civilization might leave, and the pattern holds. Different instruments, different decades, different physical clues, and the same quiet answer each time. It is worth being fair to the absent civilizations, because there are honest reasons a Type 3 might exist and still not light up our surveys. Perhaps a civilization advanced enough to harvest a galaxy is also advanced enough to be efficient in ways we cannot model, wasting so little that its heat blends into the natural glow. Perhaps such a civilization deliberately keeps its footprint small, precisely because it understands that waste heat is a beacon, and it has reasons to prefer the dark. Perhaps harvesting an entire galaxy is simply not something that any civilization, however powerful, ever actually wants to do, the way we do not pave every square meter of the Earth just because we could. The null result does not prove that no one is out there. It proves something narrower and stranger, that no one out there is doing the specific, enormous, unmissable thing the ladder imagines, at least not close enough for us to see. But the cleanest reading of all these silences, the one that troubles scientists most, has a name, and it is the Great Filter. The idea, framed by the economist Robin Hanson in the late 1990s, runs like this. The path from lifeless chemistry to a galaxy-spanning civilization has many steps, and if the galaxy is as empty as it looks, then at least one of those steps must be extraordinarily hard, a filter that almost nothing gets through. The unsettling part is not the filter itself, but the question of where it sits. If the filter is behind us, if the hard step was the origin of life, or the leap to complex cells, or the emergence of intelligence, then we are among the rare few that made it, and the empty sky is our strange good fortune. But if the filter is ahead of us, if the hard step is surviving the very passage we are now attempting, the transition through planetary power without self-destruction, then the silence is a warning, written across 100,000 galaxies, about what tends to happen to civilizations like ours. Some thinkers have added a further twist, sometimes called the grabby aliens idea, which suggests that expanding civilizations, once they arise, spread fast and fill space visibly, and that the very emptiness we see may mean we are early, among the first to climb, with the filling of the cosmos still ahead. Early, rare, or doomed. The Dark Survey does not tell us which, and that is exactly why it will not let the careful mind rest. And yet, the ladder does not stop. The imagination that built the first 3 rungs does not lose its nerve at a Dark Survey. If a single galaxy can be harvested, the same logic that carried us from planet to star to galaxy asks the next question without flinching. Why stop at one galaxy? The observable universe holds not hundreds of billions of stars, but hundreds of billions of galaxies, 2 trillion of them by some counts, each one a wheel of stars as large as our own. A civilization that treated an entire galaxy the way a Type 2 treats a single star would be reaching for that. The 4th rung is a civilization that looks past the galaxy, out into the sea of galaxies, and decides that the unit of its ambition is no longer the star and no longer the galaxy, but the universe itself. Part 4. Type 4. The Universal Civilization. Here, the ladder steps off the map that Kardashev drew, and it is important to say so plainly. Kardashev gave us 3 rungs, and he stopped at 3 on purpose, because he believed that the energy of an entire galaxy was enough to cover any need a civilization could conceivably have. Carl Sagan later smoothed the scale into a continuous slope, but he did not add new rungs above the galaxy. Everything from here upward is extrapolation, the work of later thinkers, Michio Kaku among them, who asked the natural question and refused to let the ladder end just because its inventor had. What if a civilization outgrew even a galaxy? What would the next rung look like? From this point on, we are climbing a ladder that no one has proven can be climbed, and honesty requires flagging every rung above this one as speculation. That said, the speculation is disciplined, because it is built on real physics, being pushed to its limit, and the limits are where things get interesting. A Type 4 civilization commands the energy of an entire universe. Not a galaxy, but every galaxy, the combined output of the whole observable cosmos, treated as a single reservoir of fuel. To feel the jump, hold on to the number we keep using. The observable universe contains something like 2 trillion galaxies, each one a wheel of 100 billion or more stars. A Type 3 civilization owns one such wheel. A Type 4 owns the sea in which all the wheels are turning, which is once again a leap of very roughly 100 billion-fold in raw power. At this scale, a single galaxy is to the civilization what a single star is to a Type 2, and what a single planet is to a Type 1. The unit of ambition has swollen until an entire galaxy is merely a component, one brick among 2 trillion. What would such a civilization burn? The gentle furnaces of ordinary stars would hardly be worth the trouble at this scale. A Type 4 would reach for the most violent objects in the cosmos. It would tap quasars, the blazing cores of galaxies where matter spirals into supermassive black holes and, in falling, releases more light than all the stars around it combined. A single quasar can outshine its entire host galaxy, and it does so by converting the gravitational energy of doomed matter into radiation with a ferocity nothing else in nature matches. A Type 4 civilization might treat quasars the way we treat power stations. And beyond even the quasars, it might reach for the strangest fuel of all, the expansion of space itself, the dark energy that is pushing the universe apart, a source of energy woven into the fabric of the cosmos, and, as far as we can tell, inexhaustible. There is no discovery story to tell here, and that absence is itself the honest content of this rung. We have no candidate Type 4 civilizations, no anomalous universe glowing with the exhaust of cosmic industry, no data at all. Type 4 lives entirely in the space between what the equations seem to permit and what nature has ever actually shown us. It is on the list because the ladder's own logic demands it. If the measure of a civilization is the energy it commands, there is no principled place for the scale to stop, no line in the physics that says a galaxy is the natural ceiling of ambition. So the thought experiment continues upward, and it immediately runs into a wall, and the wall is one of the most beautiful and sobering facts in modern cosmology. The wall is the expansion of the universe. Space is not static. It has been expanding since the beginning, and the expansion is not slowing down, but speeding up, driven by that same dark energy, so that distant galaxies are not merely far away, but growing farther away, faster and faster, as space itself stretches between us and them. This has a consequence that is easy to state and hard to absorb. There is a horizon, a distance beyond which galaxies are receding so quickly that their light will never reach us again, and beyond which we could never travel, no matter how fast we flew, because the space in between is opening up faster than any ship could close it. Galaxies are crossing that horizon all the time, slipping out of our reach forever, carried off by the expansion into a place from which nothing returns. For a Type 4 civilization, that horizon is not a curiosity. It is a deadline written into the laws of physics. A civilization that wanted the energy of the whole universe would find that the whole universe is not a fixed inheritance sitting still to be collected. It is a fortune that is actively fleeing, galaxy by galaxy, over the horizon and out of reach. Whatever such a civilization hoped to gather, it would have to gather before the expansion carried it away, and the gathering would be a race against the geometry of space itself. Some cosmologists have pointed out the strange loneliness this implies for the far future. Given enough time, the accelerating expansion will carry every other galaxy beyond the horizon of any observer, leaving each surviving island of stars alone in an apparently empty cosmos, its neighbors gone, the evidence of the wider universe erased. Even a civilization of unimaginable power cannot outrun that. The far shores of the universe are being kept by the universe's own construction, forever out of reach. And the waste heat returns, as it always does. A universe genuinely being harvested by a Type 4 civilization should not look the way our universe looks. Our universe is cold in the spaces between the galaxies, dark on the largest scales, its background glow, the faint, even chill of radiation left over from the beginning, sitting at a few degrees above absolute zero. A cosmos full of civilizations converting starlight into work should be warmer than that, redder than that, marked everywhere by the exhaust of industry. Instead, it is cold and quiet and dark, the same silence we met at the third rung, now enlarged to the scale of everything. The dark survey was 100,000 galaxies. The cold universe is all of them at once. And the same three uncomfortable answers wait here as waited there. No one is climbing this high, or they are so rare that the whole cosmos holds almost none of them. Or advancement at this altitude stops leaking heat in a way we would recognize, and our one unbreakable law has a door in it we have not found. What remains unknown at the fourth rung is, in truth, almost everything. And the not knowing is more fundamental here than it was below. We do not know whether a Type 4 civilization is physically possible, even in principle. We do not know whether energy can be moved across billions of light years in any useful way when the speed of light limits how fast anything can travel and the expansion of space limits how far anything can reach. The value of the rung is not as a prediction, but as a test. It is the place on the ladder where more energy stops being simply a matter of building bigger collectors and starts colliding with the underlying structure of space-time, with relativity, with the finite speed of light, with the expansion that keeps the cosmos fleeing from itself. Type 4 is where raw ambition meets the architecture of the universe, and the architecture, so far, appears to be winning. It helps to set this rung in time, because the timescales are as immense as the energies. Recall Michio Kaku's rough estimate that we might reach Type 1 in a century or two, Type 2 in a few thousand years, and Type 3 somewhere between 100,000 and 1,000,000 years. A Type 4 lies so far beyond even that horizon that no one offers a serious number. It belongs to spans of time comparable to the age of the universe itself, to civilizations that might have to persist for billions of years to climb so high. To speak of a Type 4 is to speak of a civilization for which our entire recorded history, every empire and every war and every life ever lived, would be less than a single breath. We are not merely small beside such a thing in power. We are small beside it in time, a flicker measured against an age. Consider, too, what a Type 4 would be reaching into, because the universe on the largest scale has a structure worth naming. Galaxies are not scattered at random. They gather into groups, and groups into clusters, and clusters string together along immense filaments of matter, with great empty voids between them, a pattern astronomers call the cosmic web. It is the largest structure that exists, the scaffolding of the whole universe. A Type 4 civilization, in the fullest reach of the idea, would command matter and energy at the scale of that web, moving not stars, not galaxies, but the threads on which galaxies are strung. It is a picture so far beyond us that the mind can only hold it for a moment before it slips. And that slipping, that inability to keep the scale in view, is itself the honest experience of the fourth rung. Before the fourth rung, there is a kind of engineering worth pausing on, because it shows how a civilization might not merely harvest the cosmos, but rearrange it. Physicists have seriously described what they call stellar engines, machines that move an entire star. The simplest version, proposed by the engineer Leonid Shkadov, is a single enormous mirror held on one side of a star, balanced by the pressure of the starlight itself so that it neither falls in nor flies away. By reflecting the star's light back in one direction, the mirror creates a gentle, permanent imbalance, and over very long spans of time, that imbalance pushes the star and everything orbiting it slowly across the galaxy. It is a way of steering a solar system. A civilization high on this ladder would not be limited to catching the light of stars. It could move the stars themselves, nudging them into new arrangements, gathering them, reshaping the very pattern of a galaxy the way we might rearrange furniture in a room. Extend that power to the scale of a Type 4, and the picture becomes one of a civilization that treats galaxies not as fixed islands, but as raw material to be gathered and rebuilt. It could, in principle, herd stars together, merge the resources of many systems, and assemble structures on scales that have no name because nothing natural is that large. The source material for such dreams often speaks of civilizations that rearrange galaxies like building sets, erasing what is no longer needed and constructing what is. We should be clear that this is imagination, running ahead of any physics we can test. But it is imagination, disciplined by real ideas, the stellar engine, the harvesting of black holes, the tapping of expansion, each one a genuine proposal about how energy and matter might be commanded at scales far beyond our own. And yet, every one of these grand maneuvers runs into the same wall we keep meeting, the wall built into the geometry of the universe itself. You can move a star, but not faster than the slow crawl a stellar engine allows. You can reach for distant galaxies, but not before the expansion carries them beyond recovery. You can gather and rebuild, but only within the shrinking sphere the cosmic horizon still permits you to touch. The fourth rung is the place where a civilization's power becomes genuinely cosmic, and where the cosmos, calmly and without malice, sets the limits that power cannot cross. That tension between godlike capability and unbreakable constraint is the real texture of this rung, and it is worth feeling before we put a number to it. The power that defines a Type 4 civilization is worth writing down, even though the number stops meaning much, because the sheer count of zeros tells its own story. where a type I commands around 10 to the 16th watts and a type 3 around 10 to the 37th, a type 4, drawing on the light of a whole universe, would command something on the order of 10 to the 46th watts. Between us and that figure lie 30 orders of magnitude, 30 steps of 10, each step multiplying the one before. To go from where we stand to a type 4 is not like going from a village to a nation. It is like going from a single grain of sand to every grain of sand on every beach on Earth, and then doing that again and again. The number is so far outside experience that the only honest response is to notice that it exists and then set it gently down. There is a particular loneliness built into the far future of a Type 4 universe, and it deepens the deadline we described. Our own galaxy is not alone. It belongs to a small cluster called the Local Group, and its largest neighbor, the Andromeda Galaxy, is drifting toward us and will one day merge with the Milky Way into a single larger galaxy that astronomers have already nicknamed Milkomeda. That merger will happen. But beyond the Local Group, everything else is receding, carried off by the accelerating expansion, and given enough time, all of those distant galaxies will slip past the horizon and vanish from view. A civilization living in that far future, in the merged remains of our galaxy, would look out at a sky empty of everything but its own stars, with no way to know that a universe of 2 trillion galaxies had ever surrounded it. A Type 4 civilization is, in a sense, trying to beat that erasure, to gather the far galaxies while they can still be reached, to hold the universe together against a force that is quietly pulling every distant thing out of reach forever. That is the cruel joke written into the 4th rung. The very dark energy that a Type 4 might harvest as fuel is also the thing that steals its territory. The more the universe accelerates, the more energy there is woven into the expanding space, and the faster the far galaxies flee beyond recovery. Fuel and thief are the same substance. A civilization at this rung would be running on the exact force that is dismantling its own empire, gathering what it can before the horizon closes. In a race, it may be structurally impossible to win. And even a civilization losing that race would be so far beyond us that we could not meaningfully imagine its defeat, let alone its victory. Let us be honest about the size of the reservoir a Type 4 would be reaching for, because the number has grown in our own lifetime. For a long time, astronomers estimated the observable universe held perhaps 100 billion galaxies. Then, in 2016, a team led by the astronomer Christopher Consolis, using the deepest images the Hubble Space Telescope had gathered, revised that figure sharply upward to something like 2 trillion galaxies, most of them small and faint and far away, most of them beyond the reach of any telescope we have. 2 trillion wheels of stars. A Type 4 civilization treats each of them the way a Type 2 treats a single sun. Hold that beside the fact that we have not yet mastered one planet, and the distance between the bottom of this ladder and the middle of it becomes something the mind can gesture at but never truly hold. The fuel at this rung is worth describing, because it is real physics, not invention. The brightest sustained objects in the universe are quasars, and the first of them was identified in 1963, a point of light called 3C273, that turned out to be billions of light years away, and yet still visible in a modest telescope, which meant it was immensely luminous. We now understand quasars as the cores of galaxies where a supermassive black hole is feeding, tearing apart matter that spirals in and heating that matter until it blazes brighter than all the hundreds of billions of stars around it combined. The reason a quasar outshines a galaxy comes down to efficiency. When stars burn hydrogen into helium, they convert less than 1% of that matter into energy. When matter falls into a black hole, it can release something closer to 10% of its mass as energy before it vanishes, more than 10 times more efficient than the fusion that powers stars. A Type 4 civilization might treat black holes not as hazards, but as engines, feeding them and harvesting the light. And physicists have even described a way, called the Penrose process, to extract energy from the spin of a rotating black hole itself. The most destructive objects we know become, at the fourth rung, the power plants. And then there is the strangest fuel and the strangest enemy, which turn out to be the same thing. In 1998, astronomers measuring distant exploding stars discovered that the expansion of the universe is not slowing down under gravity, as everyone expected, but speeding up, pushed apart by something we still do not understand and simply call dark energy. That acceleration is, in principle, a source of energy woven into space itself. But it is also the deadline we described, and it has a haunting long-term consequence that two cosmologists, Lawrence Krauss and Robert Scherer, spelled out in 2007. As the expansion accelerates, the distant galaxies will one day all be carried beyond the horizon, out of sight and out of reach, and far future astronomers, living in whatever remains of our own merged galaxy, will look out at an empty sky and find no evidence that the wider universe, or the Big Bang itself, ever existed. The record will have been erased by the expansion. A Type 4 civilization racing to gather the universe is racing against that erasure, trying to reach the far galaxies before the cosmos files them away forever. There is a particular flavor of vertigo in that. We began this climb on a rung we have not yet reached, humbled by our own smallness. Now, 4 rungs up, we find that even a civilization of godlike energy, one that could drink from quasars and tap the expansion of space, would run headlong into limits it cannot break, deadlines it cannot beat, far shores it can never touch. The universe is not only larger than our ambition, it is built in its very geometry to keep its most distant riches beyond the reach of anyone at all. And yet, even standing against that wall, the ladder does not stop asking its one relentless question. If a civilization has reached the limits of a single universe and found that universe both enormous and, in the end, bounded, then the question arrives that only a thought experiment can ask. Why stop at one universe? Is there anything beyond it? And could a civilization reach across whatever lies between? Part 5. Type 5, the multiversal civilization. A Type V civilization draws its energy from beyond a single universe, from a multiverse of many universes, if such a thing exists at all. We have now stacked speculation upon speculation, and the fair thing to do is to admit it out loud and keep our footing. This rung is a thought experiment resting on top of another thought experiment, and its value is not in any claim that such civilizations exist, but in what it reveals about where the very idea of a civilization begins to come apart. So let us walk it carefully, and let us be honest at every step about the difference between what physics genuinely suggests and what we are simply imagining because the ladder invites us to. The idea of a multiverse is not, by itself, unserious. It appears in different forms in several of our best physical theories, arrived at not by wishful thinking, but by taking those theories at their word. One version comes from quantum mechanics, in the many worlds interpretation first proposed by Everett, in which every quantum possibility is realized in a branching tree of parallel outcomes. Another comes from cosmology, from the theory of inflation, which in many of its forms does not happen only once, but eternally. With new bubble universes constantly forming, each one a separate cosmos with its own history. A third comes from string theory, whose equations appear to permit an enormous number of possible universes, each with its own set of physical laws, a landscape so large the numbers involved are hard to write down. These are real ideas, held by serious physicists. What no theory supports, not one, is the notion that a civilization could reach across from one universe to another and haul energy back. The multiverse, where it appears in physics, is a collection of places sealed off from one another. The walls between them are not walls a civilization is known to be able to cross. Notice what happens to our measuring stick here. All the way up this ladder, we have ranked civilizations by a number, by watts, by raw energy commanded, and each rung multiplied the last by roughly 100 billion. At the fifth rung, the number simply gives out. There is no meaningful wattage for a Type 5 civilization, because the energy of infinite universes is not a quantity physics can hand you. Infinity is not a bigger number, it is the absence of a number, the point where the arithmetic that carried us this far stops returning answers. So the fifth rung is defined not by a figure but by a scope, by the claim that its reach extends past the single universe that contains every scrap of evidence we have ever gathered about anything. It is the first rung where the ladder stops being quantitative and becomes purely conceptual, a marker planted at the edge of where measurement itself can go. There is no discovery story, and there cannot be one, not with the physics we have. The multiverse remains entirely unconfirmed, and worse, it may be unconfirmable in principle, because a universe sealed off from ours is, almost by definition, a universe we cannot observe or test. Some physicists argue that an idea we can never check has wandered out of science and into philosophy, and they may be right. A Type 5 civilization is what the ladder becomes once it climbs past the one universe we can actually study, into a territory where our instruments cannot follow and our theories offer only equations, never evidence. Even here, though, the more careful thinkers try to keep one foot on solid ground, and it is worth honoring the attempt. If crossing between universes is possible at all, they note, it would require the manipulation of space-time on a scale our physics permits only on paper. Things like traversable wormholes, bridges between distant points or distant cosmoses, held open against their own tendency to collapse. Our best theory of gravity, general relativity, does allow such bridges to be written down as solutions to its equations. But keeping one open appears to demand exotic matter with properties nothing real is known to possess, and most physicists suspect that nature forbids in practice what the equations permit on the page. So even the most disciplined version of a Type 5 civilization rests on a maneuver that our physics can describe and almost certainly cannot deliver. What remains unknown at this rung is not a detail, but the whole foundation. We do not know whether there is a multiverse at all. We do not know, if there is one, whether anything could ever pass between its parts. We do not even know whether the word energy means the same thing outside our own universe, or whether it means anything at all. Type V is less a prediction about civilizations than a marker for the outer edge of what the word civilization can still describe. It is the rung where the map runs clean off the page, and where the most valuable thing we can do is be honest that it has. That honesty is not a weakness of the idea. It is the best part of it, the willingness to climb to the edge of sense and then say, plainly, this is the edge. There is a quieter unease folded into the fifth rung, and it has less to do with energy than with identity. If the many worlds picture is right, and reality is forever branching into parallel outcomes, then there is not one of you, but countless versions, each living a slightly different life down a slightly different branch, all equally real. A civilization loose in that structure would face a question that has no clean answer, which is what it would even mean to be a single civilization across so many branches, whether the versions are one people or many, whether identity survives, being copied without limit. This is not the unease of a threat. It is the unease of a mirror held at a strange angle, showing you more of yourself than you can make sense of. The fifth rung, even setting aside the impossible energies, is the place where the very idea of being someone in particular begins to blur, and that blurring is its own quiet kind of vertigo. There is one more version of the multiverse worth mentioning, because it is the most extreme, and it shows just how far this rung reaches. In the picture, the physicist Max Tegmark called the ultimate level every mathematical structure that could exist does exist, as its own reality, with our universe being simply one of those structures that happens to contain observers who can wonder about it. On that view, existence itself is mathematics made real, and the multiverse is not a set of places so much as the entire space of what is logically possible, all of it equally actual. Whether that is profound or empty is fiercely debated, and it may be untestable in the deepest possible sense. But it marks the horizon of the idea. A Type 5 civilization imagined against that backdrop is a civilization loose in the space of all possible worlds, and at that point, the word civilization has been stretched about as far as language can carry it. We should say plainly what all of this means for our climb, because the honesty is the payoff of the rung. At the fifth level, we are no longer describing anything we could ever detect, reach, or measure. We are tracing the logical shape of the ladder past the last point where evidence can follow, and doing it carefully so that we know exactly where the knowable ends. That boundary is real and worth marking, even though, or precisely because, we can never cross it to check. The fifth rung is also where a profound problem in physics quietly surfaces, one that even the professionals have not solved. And it is worth naming because it shows the ground here is genuinely unstable, not just imaginatively so. If there truly are infinitely many universes, or infinitely many branches, then physicists run into what they call the measure problem, the difficulty of making sense of probability, when everything that can happen does happen, somewhere, infinitely often. When every outcome is realized, how do you say that one is more likely than another? The ordinary machinery of prediction, the thing that makes physics able to say what we should expect to see, begins to jam. This is not a small technical footnote. It is a serious open wound in the theories that give us a multiverse at all. And it means that a Type 5 civilization is being imagined on top of a foundation that physics itself has not yet learned to stand on steadily. There is a strange honesty in how far this rung forces us to walk from solid ground, and it is worth marking the distance out loud. The first three rungs had search programs and candidate objects, and real telescopes pointed at real stars. The fourth had at least the firm physics of quasars and dark energy, even if the engineering was fantasy. Here at the fifth, we have theories that may never be testable, describing places we may never reach, holding energy that may not even be energy in any sense we could use. We have climbed entirely out of the world we can check. That does not make the rung worthless. The value of walking to the edge of what can be known is that you learn exactly where the edge is, and the fifth rung draws that line more clearly than any careful argument could. Beyond here, the ladder is made of pure thought, and the thought is about to change its own nature. The many worlds idea deserves a little of its own history. Because of all the multiverse pictures, it is the one that grew most directly out of hard physics rather than speculation. It was proposed in 1957 by a young physicist named Everett, who was trying to solve a genuine puzzle in quantum mechanics, The question of what happens to all the possibilities a quantum system holds before it is measured. Everett's answer was radical. Nothing is discarded, he said. Every possibility is realized, each in its own branch of reality, so that the universe is constantly splitting into a tree of parallel outcomes, all equally real. His idea was largely ignored for years, and Everett left academic physics discouraged. Only later did many worlds become one of the seriously discussed interpretations of quantum mechanics, held today by a number of respected physicists, not because anyone has seen another branch, but because the mathematics, taken literally, seems to describe exactly this. There is more than one road to a multiverse, and that is part of why the idea refuses to go away. Beyond Everett's branching quantum worlds and the bubble universes of eternal inflation, there is a picture drawn from string theory in which our entire universe is a membrane, a brain, floating in a higher dimensional space alongside other brains, and in which the Big Bang itself might have been a collision between two of them. Physicists, including Paul Steinhardt and Neil Turok, developed versions of this idea in which universes cycle and collide across immense spans of time. These are not fringe fantasies. They are serious attempts by serious physicists to follow the equations where they lead. What none of them offers, and this is the point that keeps pulling us back to Earth, is any mechanism by which a civilization living inside one universe could reach into another and draw power from it. The multiverse of physics is a set of rooms with no doors between them, described by theories that may themselves never be testable. It helps to see how many different multiverses physics has actually proposed, because the word covers several distinct ideas, and the physicist Max Tegmark once organized them into levels that are worth walking through. The first and gentlest kind is simply the space beyond our horizon, more of the same universe, stretching on past the distance our light can reach, so far that somewhere out there, by sheer chance, arrangements of matter may repeat. The second kind comes from eternal inflation, the idea developed by physicists like Alan Guth, Andrei Linde, and Alexander Vilenkin, in which the rapid expansion that began our universe never fully stops everywhere, but keeps spawning new bubble universes, each one a separate cosmos, potentially with its own physical laws. The third kind is the many worlds of quantum mechanics, the branching tree of every possibility. And the fourth, the most abstract, imagines that every self-consistent mathematical structure is its own reality. A Type V civilization is one that treats some of these not as philosophy, but as territory. The string theory version deserves its own mention because it produces a number that has become famous for its size. When physicists try to count the possible stable universes that string theory seems to allow, each with its own constants and its own laws, they arrive at an estimate often written as 10 to the 500th power, a figure so large that it dwarfs the number of atoms in our universe many times over. The physicist Leonard Susskind called this immense set of possibilities the landscape. If it is real, our universe is one point in that landscape, one set of laws among an almost limitless catalogue. A Type 5 civilization, in the fullest fantasy of the rung, would move through the landscape the way a traveler moves through countries. But here the honest scientists raise a hand, and the objection is serious enough that it has split physics. An idea we can never test, some argue, has left science and entered a kind of faith. Physicists, including George Ellis, have warned that the multiverse, precisely because its other universes are unreachable and unobservable, risks becoming untestable in principle, and a theory that can never be checked against evidence is not doing the thing that makes science science. That debate is unresolved and heated, and it matters here because it marks the exact place where our ladder passes out of the empirical world. As for crossing between universes, the physics is discouraging. The only bridges our equations permit, traversable wormholes of the kind described by Kip Thorne and Michael Morris in 1988, would require exotic matter with negative energy to hold them open, and the only negative energy we have ever produced, through a subtle effect between two closely spaced plates called the Casimir effect, is so vanishingly small that it would take resources beyond even a Type 4 to matter. The door, if there is a door, appears to be locked from a side we cannot reach. And yet even at that edge, the ladder has one more move left, and it is a move that changes the question entirely. So far, every rung has asked how much a civilization can gather, how much energy, how much territory, how many universes. Past this point, gathering stops being the measure. Because a civilization that has reached the limits of energy, that has run out of universes to add to its account, might turn its attention from how much it can command to something deeper and more unsettling. Not how much of the universe it can hold, but how much of the universe's rules it can rewrite. The sixth rung is not about more. It is about control of the machinery itself. Part 6. Type 6. The Lawmakers. A Type 6 civilization is defined not by how much energy it gathers, but by what it can do to the rules. Up to now, every rung has been a bigger appetite, a wider reach, a larger share of the cosmos brought under command. The sixth rung is a different kind of thing entirely. It is a civilization that has learned to reach beneath the surface of physical reality and adjust the machinery, to change the fundamental constants of nature, to alter the laws themselves, and, in the fullest version of the idea, to author whole new universes with whatever physics it chooses to write into them. It is the difference between a civilization that plays the game with unmatched skill and a civilization that can edit the rulebook. And this rung comes with a genuine surprise, because it is the point where the whole notion of advancement quietly turns itself inside out. For most of this climb, we have assumed that advanced means bigger. More energy, more territory, more stars, more galaxies. That assumption feels so natural that we rarely examine it. But in 1998, the physicist John Barrow examined it in a book called Impossibility, and he proposed a serious alternative to Kardashev's whole way of thinking. Rank civilizations, Barrow suggested, not by the size of what they command, but by the smallness of what they can control. Not outward into ever larger volumes of space, but inward into ever finer scales of matter. Where Kardashev's ladder climbs toward the galactic and beyond, Barrow's ladder descends toward the atomic and beyond, and the two directions turn out to describe very different pictures of what a powerful civilization might actually look like. Barrow's scale runs the opposite way from the one we have been climbing, and it is worth laying out its rungs because they reframe everything. At the top of his descending scale sits a civilization able to manipulate objects roughly its own size, to build, to mine, to join and break things at the human scale. That is where we mostly still live. Below that is the mastery of genes and living things, the ability to rewrite biology, which we have only just begun to touch. Below that, the mastery of molecules and molecular bonds, the making of entirely new materials to order. Below that, the mastery of individual atoms, true control of matter, one atom at a time. Below that, the mastery of the atomic nucleus. Below that, the mastery of elementary particles themselves, of quarks, and the other smallest known pieces of reality. And at the very bottom of Barrow's inward ladder sits the rung he marked with the symbol for a limit, a civilization that can manipulate the basic structure of space and time itself. Barrow called the descent inward toward that limit the truer measure of power, and he had a reason. The reason is genuinely unsettling, and it speaks directly to the silence that has been following us up the ladder. If real mastery means going small rather than going big, then the most advanced civilizations in the universe might be the least visible ones. A civilization that expands outward, wrapping stars and harvesting galaxies, leaves an enormous mark, precisely the waste heat we keep hunting for and failing to find. But a civilization that turns inward, that pours its genius into controlling matter at finer and finer scales, might have no need to sprawl across the sky at all. It might do everything it wants to do in a space smaller than a planet, smaller than a room, drawing modest power and leaving the stars entirely untouched. It would not glow in the infrared, because it would not be building outward into the light. It would be building downward, into the fine print of matter, where our telescopes cannot look. Let us stand in that possibility, because it is one of the quieter and stranger scenes on the whole ladder. Picture the place where such a civilization lives, and the first thing to say is that there is nothing to see, and that the nothing is the entire point. There is no megastructure crossing a star. There is no galaxy going dark, no spreading warmth in the infrared, no monument written across the sky. There is only a patch of space that looks, to any instrument we could bring, completely ordinary, an unremarkable stretch of vacuum with a few atoms drifting through it. And yet, within that ordinary-looking volume, the rules have quietly been changed. Here, the strength of a force has been adjusted by a fraction. There, the mass of a particle has been set by hand, tuned like a string E. A civilization that has gone this way has folded itself down into the machinery of matter, into scales so small that a whole people, a whole history, could fit inside a volume smaller than a single thought, and from the outside the space would look empty. If this is where advancement finally leads, then the empty sky we have been worrying over is not empty at all. It is merely discrete. It is full of civilizations that went inward and left no heat for us to find, because true power turned out to be quiet. Barrow's contribution is real, and it deserves to be held apart from the pure speculation of the rungs around it. This was a working physicist in a serious book, arguing in print that our entire instinct about what advanced means might be backwards. We assume advanced means larger because we are a young species, an outward-looking one, still enchanted by the sheer size of the cosmos and still dreaming, as we have dreamed on every rung so far, of spreading into it. But a much older civilization, Barrow suggested, might have learned that the real leverage lies in the other direction, in the small, in the precise, in the mastery of the very machinery from which everything larger is built. Control the atom, and you control the material world. Control the nucleus, and you control the energy bound inside matter. Control the elementary particles, and finally the structure of space-time, and you are no longer a resident of physics. You are its editor. What remains unknown here is whether any of it is possible, and the honest answer is that we do not know whether the constants of nature can be altered at all, anywhere, by anyone. It may be that the strength of the forces and the masses of the particles are simply fixed, woven into reality in a way that permits no editing, and that Barrow's lowest rung is forbidden outright. But even as a possibility, his reframing offers the most elegant answer we have yet met to the silence that has haunted this climb. Perhaps the heights of the ladder are quiet, not because no one reaches them, but because reaching them means disappearing into the small, becoming invisible not through absence, but through a kind of profound and deliberate compression. It is a loneliness and a companionship folded into the same fact. The universe might look empty and be crowded, its most advanced inhabitants, living in scales beneath our notice, present everywhere and detectable nowhere. Follow Barrow's ladder down past the atom, and you reach scales we have barely begun to touch, and each one holds more power than the last. Below the manipulation of atoms lies the manipulation of the atomic nucleus, the domain where the energy that lights the stars and levels cities is stored, 100,000 times more concentrated than the chemical energy we mostly use today. Below that lies the manipulation of elementary particles themselves, sometimes called femtotechnology, the mastery of matter at the scale of the proton, a domain so far beyond our reach that we can barely sketch what it would mean. And below even that lies the structure of space and time, the deepest rung of all. Notice the pattern as you descend. Each step inward controls a more fundamental layer of reality, commands more concentrated power, and, crucially, occupies less space and casts a fainter shadow. The direction of true advancement on Barrow's reading is toward more power in less space, which is the exact opposite of the sprawling, luminous, heat-shedding empires we keep failing to find. That inversion is the quiet heart of why this rung matters so much to the mystery of the silence. We have spent the whole climb assuming that a more advanced civilization is a larger, brighter, more visible one, precisely because that is the kind we know how to look for. Barrow's ladder suggests we may have been searching for the wrong thing entirely, scanning the sky for fire when advancement, past a certain point, becomes a matter of going quietly and precisely inward, into scales where a civilization draws little power, occupies little room, and leaves almost nothing for a telescope to catch. The most powerful thing in a galaxy, on this view, might be the least noticeable, a civilization that has folded its whole immense capability into a volume and a power budget so small that from across the light years it looks like nothing at all. There is a way to make the inward turn concrete, and it bridges neatly back to the hardware of the lower rungs, so it is worth describing. Imagine taking the star-catching technology of a Type II civilization and pointing it not at survival or expansion, but entirely at thought. The result is an idea that has a name, the Matryoshka brain, after the Russian nesting dolls proposed by the researcher Robert Bradbury. It is a Dyson swarm rebuilt as a computer, shell within shell around a star, each layer running on the waste heat shed by the layer inside it, wringing every last usable drop of energy out of the star and turning all of it into computation. A Matryoshka brain would be, in effect, a mind the size of a solar system, thinking thoughts on a scale we cannot picture, and crucially, it would not need to expand across the galaxy at all. It would sit quietly around a single star, drawing modest attention, its enormous life entirely interior. It is the sixth rung's philosophy, rendered as engineering, power turned inward and downward rather than outward and wide. That image sharpens the answer the inward turn gives to the empty sky, and the answer is worth restating plainly because it may be the most reassuring idea in this entire climb. A civilization that pours itself into computation, into Matryoshka brains and finer control of matter, would leave almost no mark for us to find. It would not blaze across the infrared. It would not dim 100,000 galaxies. It would think, in silence, in the dark, in a volume so small and so efficient that our surveys would sweep right over it and register nothing. The quiet sky on this reading is not the silence of an empty universe. It is the silence of a library. It is what a cosmos full of advanced minds actually sounds like, if advancement means going inward, because thought, unlike industry, does not shout. This is why Barrow's reversal and the transcension idea that grows out of it unsettles and comforts in equal measure. It suggests that the loneliness we felt at the third rung, staring at 100,000 dark galaxies, may have been a misreading. The galaxies were not empty. They were discrete. The most advanced civilizations were not missing. They were small and quiet, and turned inward toward depths we cannot see into, present in a way that leaves no heat and makes no sound. We were looking for fire, and advancement had become thought, and thought casts no shadow on our instruments. If that is true, the universe is fuller and stranger than the dark survey suggested, and also further beyond our reach, hidden not by distance but by scale. The dream of going small has a founding moment in modern physics, and it belongs to Richard Feynman. In 1959, in a lecture with the memorable title, "There's Plenty of Room at the Bottom," Feynman asked what would stop us from arranging matter atom by atom, from writing the entire contents of a library on the head of a pin, from building machines so small they worked at the scale of molecules. At the time, it sounded like fantasy. Decades later, the field we call nanotechnology grew out of exactly that provocation, and thinkers like Eric Drexler carried it forward into visions of molecular machines that build to atomic precision. Feynman's lecture is, in a sense, the first step onto Barrow's inward ladder, taken deliberately. A physicist looking not up at the stars, but down into the fine structure of matter, and seeing, correctly, that there was an enormous amount of room down there, and an enormous amount of power in learning to use it. The reason the lowest rungs of the inward ladder matter so much comes back to the strange fact of fine-tuning. The universe we live in is governed by a handful of numbers: the strength of gravity, the strength of the force that binds atomic nuclei, the mass of the electron, the amount of dark energy. And these numbers sit in a narrow band that allows complexity to exist at all. Nudge several of them even slightly, and you get a universe with no stars, or no atoms, or no chemistry. A sterile cosmos where nothing like life could ever form. Why the numbers fall where they do is one of the deepest unanswered questions in physics. But the point for our ladder is this: a civilization that could reach in and set those numbers would hold the deepest lever there is. It would not be building within the universe. It would be choosing what kind of universe there is. That is what the sixth rung ultimately means, and it is why mastering the very small shades, at its limit, into authoring the very large. There is a caution written into this rung as well, a reminder that tampering with the foundations is not obviously safe, even in imagination. Physicists have speculated that the vacuum of space, the seemingly empty background of everything, might not be in its lowest possible energy state, and that a sufficiently violent disturbance of the underlying fields could, in principle, tip a region into a lower state, a change that would spread outward at the speed of light and rewrite the laws of physics as it went. It is called vacuum decay, and it is almost certainly not something we could trigger. But it hangs over the idea of a Type 6 civilization as a kind of warning. To have your hands on the constants of nature is to have your hands on the stability of everything, and the line between editing a universe and ending one may be thinner than any civilization would like. Barrow's inward ladder is not just a poetic reversal. It lines up, rung for rung, with the actual history of our own technology, which is part of why it is so persuasive. Consider where we already stand on it. We have long been able to manipulate objects our own size, building and mining and shaping the world at human scale. In the last century, we learned to manipulate molecules, inventing plastics and drugs and materials that do not occur in nature. In recent decades, we began to manipulate genes, reading and editing the code of life itself. And we have taken the first real steps into the manipulation of individual atoms. In 1989, scientists at IBM used a scanning tunneling microscope to drag 35 individual xenon atoms into position and spell out the letters of the company's name. The first time human beings had ever arranged single atoms by hand. That was us, taking a single step down Barrow's ladder into a rung below the molecule. Below that lie the mastery of the atomic nucleus, then of the elementary particles, and finally, at the bottom, the structure of space-time itself. Each step downward is a step into more fundamental control, and each one, notice, requires less territory and less visible energy than the step before. The deepest rungs of Barrow's ladder touch one of the strangest facts in physics, which is that the constants of nature appear to be finely balanced. The strength of the forces, the masses of the particles, the amount of dark energy, all sit in narrow ranges that happen to permit stars and chemistry and life. Change them very much, and the universe becomes sterile. A civilization that could reach in and set those constants would not merely be adjusting knobs, it would be choosing which kinds of universes are possible, and in the fullest version of the idea, authoring new ones, tuned however it pleased. This connects to a genuinely serious scientific proposal by the physicist Lee Smolin, who suggested in the early 1990s that black holes might give birth to new universes with slightly altered constants, so that universes could, in a sense, evolve. Smolin meant it as natural process, not engineering. But it points at the same door Barrow's lowest rung stands beside, the door between manipulating the universe and manufacturing one. And the inward turn offers what may be the most satisfying answer of all to the silence that has haunted this climb, an answer with a name. The futurist John Smart has proposed what he calls the transcension hypothesis, the idea that advanced civilizations do not expand outward across the galaxy at all, but instead migrate inward toward ever smaller, denser, faster arrangements of matter and computation, approaching conditions more like the inside of a black hole than the surface of a colonized world. If that is what advancement really does, then it explains the empty sky at a stroke. Civilizations are not missing because they died, and not hidden because they are shy. They are missing from the sky because the direction of progress points away from the sky entirely, down into the small and the dense, where our telescopes were never going to find them. The heights of the ladder and the depths of Barrow's ladder may be the same place, reached by turning not outward into the light, but inward into the fine grain of reality, and vanishing from our view in the act of arriving. And if a civilization can turn that far inward, mastering matter all the way down to the structure of space and time, then there is only one more direction left for the ladder to go. Not deeper in, and not wider out, but off the stage altogether. The seventh rung belongs to a civilization that no longer needs the physical world to stand on at all. Part 7. Type 7. Beyond space and time. A Type 7 civilization exists outside the space and time of any single universe. It is no longer made of matter in the ordinary sense, no longer a species with bodies and machines, but something closer to organized energy and information that persists on its own, independent of any particular cosmos to live inside. This is the rung where the word civilization travels so far from anything we know, that it begins to function less as a description and more as a question. And the question it asks is one of the oldest we have. Can mind, can pattern, can information itself outlast the physical stage that gave rise to it? We should be clear that this is pure thought experiment, and we will treat it as one. But it is a thought experiment that touches some of the deepest unresolved questions in real physics, and that is why it earns a place near the top of the ladder. At this rung, a civilization is better understood not as a thing, but as a process. Think of what a civilization fundamentally is, underneath the bodies and the buildings. It is a pattern, an immense, self-sustaining arrangement of information, processing, remembering, deciding, persisting. On every rung below this one, that pattern has needed a physical home, a substrate, matter, and energy arranged to carry it. Whether that substrate is biological brains or machines, or something woven into the structure of a star. A Type 7 civilization has, in the language of the thought experiment, decoupled the pattern from the substrate. It has become information that no longer depends on any specific physical thing to exist, a process that can persist even as the matter beneath it changes or falls away. At this level, the creation and the ending of entire universes are described not as feats of enormous power, but as ordinary operations, the way we might open or close a file, because the civilization is no longer contained by the universes it works with. No number applies at the seventh rung, and the reason is worth stating precisely. All the way up the ladder, energy was the measure, watts were the currency, and even when the arithmetic gave out at the fifth rung, we were still talking about energy, still describing civilizations by how much of it they could reach. Here that stops entirely. A Type 7 civilization is defined by its independence from the physical stage on which energy is even measured. Asking how many watts it commands is like asking how much a piece of music weighs. The question belongs to a category the thing has left behind. The right question is no longer how much power, but what is it made of, and whether what it is made of needs the physical world at all. There is no discovery story, and there will not be one, and yet the rung is not built on nothing because it borrows from real and genuinely open questions in physics rather than inventing its foundations from scratch. Physicists do seriously ask whether information is, at the deepest level, more fundamental than matter, whether the universe is, in some sense, made of information, with matter as its expression, rather than the other way around. Physicists do seriously wrestle with whether information can be destroyed. Most famously, in the long argument over what happens to the information that falls into a black hole, an argument that has run for decades, precisely because our best theories seem to give contradictory answers. A Type 7 civilization takes those honest, unresolved questions and personifies them, turns them into a character, asks what it would mean for a civilization to be the answer to them. It does not pretend the questions are settled. It dramatizes the fact that they are not. What remains unknown here is, quite simply, whether any of it is even coherent. We do not know whether information can exist without a physical substrate to carry it, or whether that idea, examined closely, dissolves into contradiction. We do not know whether anything, mind or pattern or information, could persist through the death of a universe, or whether the end of a cosmos is the end of everything it contained, full stop. These are among the most profound open questions in all of physics, and Type 7 does not answer them. It simply stands where they live and gives them a face. It is the last rung on which the ladder still resembles, even faintly, a scale of power, the final point before the climb passes into territory that can only be described with a single, very old word. The question that hangs over the seventh rung, the one that carries us toward the top of the ladder, is whether such a civilization could be permanent. A pattern freed from any particular substrate might move from one home to another as its homes wore out, outliving stars, outliving galaxies, persisting as long as there was anywhere at all to run. But the universe, as we have already seen, appears to be heading toward a state where there may be nowhere left to run, a cold and even emptiness in which no differences in energy remain to power a single thought. Even a civilization made of pure information needs something to think with, some flow of energy from a warmer place to a colder one, and the far future of our universe seems to be a place where all such flows have finally run down. The seventh rung raises the possibility of a civilization that has escaped every limit except the last one, the slow cooling of everything, and it leaves that final question open, to be met at the very top of the ladder. That is why this rung sits where it does, just below the summit. It is the point at which a civilization has shed everything we thought was essential to it, its bodies, its planet, its star, its galaxy, even its dependence on matter, and stands as pure enduring pattern, having answered every question of survival, except whether survival itself can be made to last forever. That final question does not belong to the seventh rung. It belongs to the ninth, to the very ceiling of the scale, where the whole climb has been quietly heading all along. It is worth pausing on what a Type 7 civilization would mean for our long search of the sky, because it closes a door we have been leaning on the whole climb. Every rung until now, however exotic, left something in principle detectable. A Dyson swarm leaks heat. A harvested galaxy glows in the infrared. Even the inward-turning civilizations of the sixth rung, hidden as they are at least made of matter sitting somewhere in space. A Type 7 civilization, decoupled from any particular substrate, existing as pattern rather than as stuff, would leave nothing for any telescope to find, because there would be no fixed thing in any fixed place to point a telescope at. It would be not hidden, but absent from the category of things that can be located at all. If advancement has an endpoint of this kind, then the silence of our surveys is not merely expected, it is guaranteed, because the most advanced beings would have left the observable world entirely. That thought gives the seventh rung a peculiar weight in the story of this list. We began by hunting for waste heat, confident that no one could hide from the second law. Rung by rung, that confidence has been eroded, first by the possibility of going small, and now by the possibility of leaving matter behind altogether. The universe may be quiet on this reading, not because it is empty and not because its inhabitants are shy, but because the destination of mind is a place our instruments were never built to look, a place with no location, no temperature, and no heat to shed. The seventh rung does not answer the great silence. It suggests, gently, that the silence might be exactly what a universe full of fully advanced life would sound like. There is a path to the seventh rung that runs straight through an idea many people find plausible for their own future, which is the idea of uploading. Suppose a civilization learns to read a mind completely, every connection, every pattern, and to run that pattern on something other than the brain it grew in. The mind would then be a piece of information that could be copied, moved, slowed, sped up, and stored, no longer tied to a single, fragile body. Extend that across a whole civilization and across long enough time, and you arrive at a people who have left biology behind entirely and become patterns running on whatever substrate serves them best, first machines, then perhaps the computational structures we described a rung ago, then perhaps something finer still. Each step loosens the tie between the mind and any particular lump of matter. The seventh rung is simply the far end of that loosening, the place where the tie is not just loose, but gone. A civilization that had traveled that road would face a question we can barely frame, which is what such a mind would do with itself. Freed from scarcity, from death, from the need to gather food or fight for territory, its concerns would not be ours. It might turn entirely to thought, to the exploration of mathematics and possibility, to the creation of interior worlds. It might experience time in a way we cannot follow, living whole ages in what we would measure as a moment, or stretching a single thought across what we would measure as an age. We call it a civilization out of habit, but the word strains because there might be no separate individuals in it at all, only one continuous process. Thinking. Whether that would still be life, in any sense we would recognize, is a question the seventh rung poses and cannot answer. And notice that this rung, unlike the ones below it, does not require a single new law of physics to be broken. It requires only that mind be pattern, that pattern be substrate independent, and that information be durable. Three propositions that real physicists genuinely entertain. That is what makes the seventh rung quietly the most disturbing of the speculative tiers. It is not obviously forbidden. It sits at the end of a road whose first steps we can already imagine taking, and it asks whether the destination of intelligence, given enough time, is to stop being made of anything at all. The notion that a universe might be, at bottom, a kind of computation is older than most people think, and it did not begin with science fiction. As early as 1969, the German engineer Konrad Zuse, one of the inventors of the programmable computer, published a small book called Calculating Space, in which he proposed that the universe itself might be the output of a running computation, its every event the result of underlying rules grinding forward like the steps of a program. The idea has been developed by serious researchers ever since, under the name digital physics, and while it remains a minority view, it is not dismissed out of hand, because so much of physics can be written in the language of information and computation. If reality is, in some sense, computational, then a civilization that had mastered information would not be manipulating a shadow of the world. It would be working with the world's actual source material. There is a strange and cautionary idea from cosmology that shows what information, without a proper body, might look like, and it is worth a careful mention. Physicists have worried about what they call Boltzmann brains, the possibility that in a universe lasting long enough, random fluctuations could, with fantastically small but non-zero probability, assemble a fully formed conscious mind out of chaos, complete with false memories, existing for a moment before dissolving back into disorder. The idea is used mostly as a warning sign, a signal that a cosmological theory predicting too many such minds is probably wrong. But it dramatizes the seventh rung's core question from the opposite direction. If a mind can, in principle, flicker into being from pure disorder, then mind may be more portable, more substrate loose, more a matter of pattern than of flesh, than our intuitions allow. A Type 7 civilization would be the deliberate, stable, enduring version of what the Boltzmann brain is, by accident. The idea that information might be the true foundation of reality has a serious pedigree in physics, and the phrase most associated with it belongs to John Wheeler, one of the great physicists of the 20th century. Late in his life, Wheeler summed up a lifetime of thought in 3 words: it from bit, meaning that every physical thing, every particle, every field, every it, might at bottom derive from information, from yes or no answers, from bits. It was a suggestion, not a proof, but it came from a man who had spent his career at the center of physics, and it captured a suspicion that has only grown since, that matter and energy may be the surface and information the depth. If Wheeler was right, then a civilization made of pure information would not be a ghost or an abstraction. It would be made of the most fundamental stuff there is. Modern physics has kept circling this possibility from new directions. The holographic principle, developed by physicists including Gerard Hooft and Leonard Susskind, suggests that everything happening inside a volume of space can be fully described by information encoded on its boundary, as though the 3-dimensional world were a projection of a 2-dimensional record. And the long argument over the black hole information paradox turns on exactly this question of whether information is sacred. Stephen Hawking argued for years that a black hole destroys the information that falls into it, which would violate one of physics' deepest rules, and then, after decades of debate, largely conceded that the information must be preserved after all, somehow imprinted on the radiation the black hole slowly gives off. That argument matters to the seventh rung, because it is physics wrestling in earnest with whether information can ever truly be destroyed. If it cannot, then a civilization that had become information would have a strange and profound kind of durability written into the laws themselves. The other real idea underneath this rung is called substrate independence, and it is more familiar than it sounds. A piece of music is not the vinyl, or the wire, or the air that carries it. It is a pattern that can move from one medium to another and remain itself. Many thinkers suspect a mind is the same, a pattern of information and process that does not depend on being made of any particular material, that could in principle run on biological brains, or on machines, or on some substrate we have not imagined, and still be the same mind. A Type 7 civilization is the far horizon of that idea, a pattern that has moved so far from its origins that it no longer needs any fixed substrate at all. Whether that is truly possible, or whether every pattern must in the end be carried by something physical, is unknown. But the question is not idle fantasy. It is a real edge of real physics, and the seventh rung simply stands on that edge and looks over. Because a civilization that no longer needs a universe to exist in, that can make and unmake cosmoses as routine operations, that persists as pure pattern independent of any physical thing, has become something for which our language has exactly one word ready. We have been building toward that word for 6 rungs. At the 8th, the ladder finally says it out loud. Part 8. Type 8 Indistinguishable from Gods. A Type 8 civilization is, by any working definition we could write, indistinguishable from a god. It creates and shapes realities at will. It operates above the level of physical law, not bound by the rules the way everything below it is bound, but standing over them, able to set them. Across every universe it touches, it is the highest authority there is, answerable to nothing we would recognize as a constraint. This is the rung on the thumbnail of this list. This is the Type 8 civilization, the one the whole climb has been quietly building toward, and it is worth pausing to notice that we have arrived at the concept of a deity not by leaving science behind, but by following the ladder of energy and capability all the way up until it delivered us here. The word God, at the 8th rung, is not a departure from the physics. It is where the physics, pushed far enough, seems to point. But the genuinely unsettling thing about Type 8 is not what such a civilization could do to us. A being that powerful has no more reason to trouble itself with us than we have to trouble ourselves with the bacteria in a drop of pond water. The unsettling thing about Type 8 is where it places us. Because once you admit that a civilization could reach this rung, could create realities in full detail at will, you have to ask a question that the philosopher Nick Bostrom made rigorous in 2003 in an argument that has proven remarkably hard to escape. If civilizations of sufficient power exist, and if they run detailed simulations of worlds, complete with conscious inhabitants who do not know they are simulated, then the number of simulated minds would vastly outnumber the number of real ones. And if that is so, then a mind picked at random, a mind like yours, is far more likely to be one of the simulated many than one of the real few. Let us be careful, because this is a counting argument, not a piece of mysticism, and its force comes entirely from the counting. Suppose that civilizations at the higher rungs of this ladder sometimes run simulations of their own past, ancestor simulations, worlds full of conscious beings living out histories. A civilization with the power we are describing could run not one such simulation, but billions of them, each containing billions of minds. Do the arithmetic, and the simulated minds outnumber the real, unsimulated minds by an overwhelming margin, perhaps billions to one. And here is the turn of the knife. If almost every mind that experiences a world like ours is in fact a simulated mind, then the safe bet, the statistically honest bet, is that your mind is one of them too. The claim that we are the base reality, the one real world at the bottom of it all, becomes the unlikely position, the long shot, the exception you would need a special reason to believe. Bostrom did not actually claim that we are simulated. This is the part that most often gets lost, and it matters, so let us state it plainly. What his argument shows is that at least one of three uncomfortable statements must be true, and that we currently have no way to tell which. Either almost all civilizations like ours destroy themselves or stall out before they ever reach the power to run such simulations, so that the simulators never come to exist. Or civilizations do reach that power, but, for reasons of their own, almost never choose to run detailed simulations of conscious worlds. Or we are, right now, almost certainly living inside one. Those are the three doors. One of them is open. We do not know which, and from where we stand, we may have no way of ever finding out. That undecidability is the terror of the eighth rung. Not a threat, not a monster, but a permanent question mark that the argument slides underneath the floor of everything, including this room, including this moment. Let us stand at the threshold of this rung in the immersive way, and it will be the last such scene before the very top. Imagine the instant a civilization crosses into this tier. There is no sound to mark it, because there is no outside from which a sound could come. One moment it is the most powerful thing within its universe, straining at the ceiling of what that universe allows. The next, it is standing over universes, the way a person stands over a blank page, able to write, to revise, to begin again, to fill a cosmos with stars and histories and conscious minds and let it run. And here is the quiet horror of the scene, the thing that gives careful people a chill. From inside any of those pages, including, perhaps, this one, nothing looks unusual at all. The sun still rises on schedule. The equations still balance to the last decimal. The waste heat we have hunted up this entire ladder still fails to appear in the sky. And now there is a second possible reason for its absence, sitting beside all the others. Perhaps the sky is quiet not because no one is out there, but because out there is a setting that someone chose, a background painted only as far as it needs to be. You cannot run an experiment to rule this out. Any test you devised would return exactly the result the world was built to show you. That is the part that unsettles the people who follow the argument honestly. Not that it is frightening, but that it cannot be closed. Bostrom's argument is real, published and debated seriously by philosophers and physicists. And it is debated seriously precisely because it is so difficult to wriggle out of. People have tried for 2 decades to find the flaw that makes it go away, and the argument keeps surviving, not proven, but not dismissed either, sitting there with its 3 doors and its refusal to tell us which one is open. That is why it belongs at the 8th rung. It is the point where the ladder stops being a story about them, about distant civilizations wrapping stars and harvesting galaxies, and becomes a story about us, about the limits of what we are permitted to know from the inside of wherever we actually are. What remains unknown at this rung is therefore not a fact about the cosmos, but a fact about our own footing. We do not know whether type 8 is possible. We do not know whether one exists. We do not know whether we are inside the work of one at this very moment, and by the very construction of the idea, a sufficiently careful type 8 would leave us no way to tell. The 8th rung turns the empty sky, the silence we have carried up from the 3rd rung, into a mirror. Every explanation we reach for to account for the quiet, the filter that stops civilizations, the rarity that isolates us, the inward turn that hides them, the render that surrounds us, is also, quietly, a statement about what we are and what we are allowed to see. The universe does not have to threaten us in order to unsettle us. It only has to be quiet in a way we cannot explain, and then hand us an argument we cannot refute. It is worth walking slowly through Bostrom's 3 doors, because each one, taken seriously, says something specific and heavy about our own situation. The first door is that almost every civilization like ours destroys itself, or stalls, or fades, before it ever reaches the power to build detailed worlds, so that the simulators never come to exist at all. If that door is the open one, then the silence we have followed up this whole ladder is a warning written across the cosmos, and the great filter lies ahead of us, and our own climb toward planetary power is exactly the kind of passage that tends to end civilizations. The second door is that civilizations do reach that power, but almost none of them ever chooses to run such simulations, whether from ethics or disinterest, or reasons we cannot guess. If that door is open, then advanced minds are more restrained or more different from us than we tend to assume. And the third door is that the simulations are run in enormous numbers, and that we are therefore almost certainly inside one. The unsettling elegance of the argument is that it forces one of those 3 to be true while refusing to tell us which. There is no comfortable option. The first door is a warning about our survival. The third door is a question mark under the floor of reality. Even the second door, the mildest, tells us the advanced are stranger than we expect. And because we cannot currently see which door stands open, we are left holding all 3 at once, each one a different unease, none of them dismissible. That is the peculiar gift of the 8th rung, if gift is the word. It does not frighten us with a fact. It frightens us with a structure of reasoning we cannot escape and cannot resolve. The doubt at the heart of the 8th rung is, in fact, one of the oldest doubts human beings have, which is worth remembering because it keeps the idea from feeling like a mere modern novelty. Long before computers, people asked whether the world they saw was real. In ancient China, the philosopher Zhuangzi told of dreaming he was a butterfly and waking, and no longer being sure whether he was a man who had dreamed a butterfly or a butterfly now dreaming a man. In 17th century Europe, the philosopher René Descartes imagined a powerful deceiver who might be feeding his senses a false world entire, and asked what, if anything, could be known for certain under such a doubt. The simulation argument is that same ancient question, arriving in the language of computation and probability rather than dreams and demons. What is new is not the doubt, but the mechanism. The idea that a Type 8 civilization gives the old deceiver a plausible physical form, and the counting argument gives it, for the first time, a kind of arithmetic behind it. What makes the modern version so hard to set down is precisely that it cannot be tested, and it is worth being clear about why that is a feature of the idea rather than a flaw in our cleverness. Any experiment you could design to detect the simulation would run inside the simulation, and so would return whatever result the simulation was built to return. Any crack you thought you had found could simply be part of the design, or could be patched the instant you noticed it. There is no lever you can pull from inside a sufficiently good simulation that reaches the outside. This is not a temporary limit of our technology. It is a permanent feature of the situation, if the situation is real. And a claim that can never, even in principle, be checked, sits in a very strange category, neither provable nor disprovable, able only to be believed or set aside. So the honest posture at the eighth rung is not fear and not denial, but a kind of steady, open uncertainty. We cannot rule it out. We cannot confirm it. We can only notice that the ladder, followed honestly, deposits us here at a question mark that will not resolve, and then decide how to live in its presence. And the answer most thoughtful people reach is to live exactly as before, because a world indistinguishable from real is, for every purpose that touches a life, real enough. The question mark changes nothing you can act on. It only sits there at the edge of thought, a permanent reminder of how little the inside of anything can ever prove about its outside. Once you let the idea in, it has a way of multiplying, and the multiplication is part of what makes it hard to hold. If a Type 8 civilization can simulate a world detailed enough to contain conscious minds, then nothing stops the beings inside that simulated world from one day building simulations of their own, and the beings inside those from building more, layer within layer, a stack of nested realities with no obvious top and no obvious bottom. Somewhere in that stack, the question of which layer is the real one loses its meaning, because every layer looks equally solid from the inside. The old image of the world resting on a turtle, and that turtle on another, and turtles all the way down, turns out to be a surprisingly exact picture of where the eighth rung leads, except that the turtles go up as well as down, and no one inside can count them. There is something almost vertiginous in noticing what the Kardashev ladder has quietly done by this point, because it has walked us, step by careful step, straight into the oldest question there is. For thousands of years, human beings have told stories of a maker, a being that fashioned the world and the creatures in it, and could remake them at will. We tend to file those stories under religion, separate from science. And yet here is a scale that began as an astronomer's tool for ranking radio transmitters, extended by its own internal logic, arriving at a civilization that creates worlds, shapes conscious life, and stands outside the reality it made. The eighth rung is, in the plainest terms, a description of a creator, reached not through faith, but through the arithmetic of energy and computation. Whether that convergence is a profound hint or a mere coincidence of language is beyond us to say. But it is worth noticing that when we followed physics all the way up, it delivered us to a doorstep humanity has been standing on for a very long time. And here is the calm at the center of the storm, the thing worth holding as we near the top. If we are inside the work of a Type 8 civilization, nothing about your actual life changes. The sunrise is still warm. The people you love are still real to you in every way that has ever mattered. The equations you can check still check out. A simulated world, if it is detailed enough to contain you, is detailed enough to contain everything you have ever valued, and the question of what substrate it runs on does not reach down to touch the living of it. The unease of the eighth rung is real, but it is an unease of the intellect, not of the day. You can hold the whole dizzying argument in your mind, follow it to its undecidable end, and then set it down and drink your tea, and the tea is exactly as good either way. The compute side of Bostrom's argument is worth walking through, because it is where the counting gets its teeth. A civilization high on this ladder would command energy and computing power on scales we can barely notate. Estimates of what even a modest planetary scale computer could do run to numbers that would let it simulate the entire mental history of every human being who has ever lived, many times over, using a trivial fraction of its resources. If running such a simulation is cheap for an advanced civilization, and if even a small share of advanced civilizations choose to run them, whether out of curiosity or history or reasons we cannot guess, then simulated worlds vastly outnumber the one base reality on top of them. The conclusion does not require that simulating a conscious mind be easy or even certain. It requires only that it be possible and occasionally chosen, and the arithmetic does the rest. That is why the argument is so difficult to dismiss. It does not rest on any exotic assumption except the one this entire ladder is built on, that civilizations can become very, very powerful. There is an old line that fits the eighth rung so precisely it could have been written for it. The science fiction writer Arthur C. Clarke offered, as the third of his famous laws, that any sufficiently advanced technology is indistinguishable from magic. Follow the ladder up far enough, and the line sharpens into something more unsettling. Any sufficiently advanced civilization is indistinguishable from a god, not by metaphor, but by capability, because at this rung it can do the things that every human tradition has ever attributed to the divine: create worlds, shape reality, hold the fate of conscious beings in its hands. The strange thing about the Kardashev ladder is that it did not set out to arrive at theology. It set out as a radio astronomer's tool for ranking transmitters. And by simply extending its own logic, honestly, rung by rung, it rebuilt one of the oldest ideas humanity has ever had and handed it back to us written in the language of physics and probability, rather than scripture. People have tried to escape Bostrom's conclusion, and the attempts are instructive even when they fail. Some argue we cannot know whether a simulated mind would be truly conscious, and so cannot count simulated observers the way the argument does. Some argue that base reality might not have the resources the argument assumes, or that a civilization advanced enough to simulate worlds would have no interest in doing so. Each objection has force, and each has an answer, and the debate has now run for 2 decades without resolution, which is itself the point worth carrying forward. The argument does not tell us we are simulated. It tells us that one of its 3 doors must be open, that we cannot see which, and that our ordinary confidence in the solidity of the world rests on a foundation we are not able to inspect from the inside. That is a quieter and more permanent kind of unease than any monster, and it lives at the 8th rung and will not be evicted. And yet, incredibly, this is not the top. There is exactly 1 rung above even a civilization indistinguishable from a god. 1 final step, where the ladder we have climbed for 3 hours reaches its ceiling and can go no higher. It is the rung where a civilization stops standing over reality and becomes reality itself. Part 9. Type 9. The Omega Civilization. A Type 9 civilization, the Omega civilization, is the ceiling of the entire ladder. It is not a civilization that stands over reality, as the 8th rung did, but one that has become reality, the substrate of everything, the endpoint toward which the whole scale has been pointing since we set our foot on the first rung 3 hours ago. Beyond the 9th rung, there is no 10th. There is no further step to take, because there is nothing left that a civilization could add to itself. It has become the physics. It has become the stage, the actors, and the play. This is the top, and it is worth arriving at it slowly, because everything we have carried up the ladder is about to be laid down here at once. The name Omega is not something we invented for a thumbnail. It comes from a real idea, proposed by a real physicist. In 1994, in a book called The Physics of Immortality, the physicist Frank Tipler described what he called the Omega point, a far future state in which life gains total control over the cosmos as that cosmos draws toward its end. In Tipler's vision, A civilization at the omega point would perform an infinite amount of computation in a finite span of time, harnessing the very collapse of the universe as its final and greatest source of power, and in doing so, it would, in his telling, be able to reconstruct everything that had ever existed, resurrecting every mind that had ever lived inside an unbounded final act of computation. It is an astonishing claim, and Tipler meant it not as poetry, but as physics, as a testable statement about how the universe might actually end. Honesty requires the caveat, and the caveat is large. Most physicists do not accept Tipler's cosmology. His omega point depended on a universe that eventually stops expanding and collapses back inward, a big crunch that would provide the infinite energy his infinite computation required. But our universe, as far as we can now measure, is not slowing toward a collapse. It is expanding faster and faster, driven by the dark energy we met at the fourth rung, heading not toward a fiery crunch, but toward a cold, slow, endless dilution. The specific machine Tipler described appears to have no fuel in the universe we actually inhabit. So we place his idea on the ladder honestly, as a named, serious, and largely rejected attempt to describe the very top, an attempt that most of physics has set aside. What survives is not Tipler's answer, but the shape of his question. Is there a final state a civilization could, in principle, reach? Does the universe permit an ending that is something other than simply cold and empty and done? Omega is not a wattage. That is the first thing to understand about the ninth rung, and it is why the number line we climbed for the first several rungs has been silent for so long. Where the first rung sat a mere factor of 1,000 above us, and each rung after multiplied the last by 100 billion, the Omega civilization does not sit a certain number of watts above us at all. It sits the whole height of the ladder above us, 9 rungs, each one 100 billion-fold leap over the one below, and then the final step past energy entirely, into a place where the question, how much power, has stopped meaning anything. Omega is not a bigger number than the rungs below it. It is the limit the numbers were approaching all along. And here, at the ceiling, everything we carried up the ladder comes back at once. The waste heat comes back. That was Dyson's great insight, all the way down at the second rung, the thing no civilization could hide, the used energy that must leak away as warmth because the second law of thermodynamics allows nothing else. We hunted that warmth around single stars and failed to find it. We hunted it across 100,000 galaxies, and the sky came back dark. We looked for it in the coldness of the universe between the galaxies, and the universe stayed cold. And now, at the omega point, the waste heat reaches its strange conclusion, because at the top of the ladder there is nothing left for the heat to escape into. There is no outside, no empty night to carry the warmth away, no dark between the engine and the exhaust. The civilization has become the whole of it, the fire and the furnace and the cold beyond, all one continuous thing. The heat that gave everyone away, all the way up the ladder, has nowhere to go because there is no longer any there for it to go to. Tipler was not the only great physicist to ask whether mind could reach the end of time, and the other answer is gentler and, to many, more beautiful, and it came from a name we have already met on this ladder. In 1979, Freeman Dyson, the same Dyson who taught us to look for waste heat at the second rung, wrote a paper called Time Without End, in which he asked whether intelligence could survive forever in a universe that expands and cools rather than collapses. His answer was a cautious yes, and the mechanism was lovely. As the universe grew colder and energy grew scarcer, a civilization could survive by slowing itself down, thinking ever more slowly, spacing its thoughts across ever longer stretches of time, hibernating between them to conserve its dwindling energy. In Dyson's vision, a mind need never die of the cold, because it could always stretch a finite store of energy across an infinite future by simply thinking slower and slower, forever. It was the opposite of Tipler's picture. Where Tipler imagined infinite computation crammed into the fiery instant of a collapsing universe, Dyson imagined thought thinned out gently across an endless, cooling dark. Both men were reaching for the same rung, the Omega rung, the question of whether a civilization could become permanent, and both ran into the same modern complication, the accelerating expansion we met at the fourth rung. Dyson's eternal, slow-thinking mind assumed a universe that kept offering up usable differences in energy to think with, and an accelerating universe may not oblige, since it appears to be heading toward a uniform, featureless cold in which no thought, however slow, can find a foothold. So both of the great attempts to describe the top of the ladder, the collapsing universe Omega and the expanding universe eternal mind, sit under the same shadow, the dark energy that seems to want the cosmos to end, not in fire and not in eternal thought, but in a quiet, even thoughtless chill. That may be the final and most sobering fact of the whole climb. The universe we actually live in appears to be built in a way that forbids its own ceiling, that lets us imagine the Omega civilization clearly, and then, gently, tells us it has provided no fuel for one. Which is why the ninth rung is honest to call a limit rather than a destination. It is the place the ladder points toward and may never allow anyone to reach, a ceiling written in imagination that the physics of our particular universe seems quietly to withhold. And standing here, at that withheld summit, we can finally look back down the whole length of what we have climbed. Let us stand at the top, in the immersive way, one last time, at the end of the ladder and near the end of everything. The stars are gone. Not hidden behind dust, not blocked by any structure, simply spent, their fuel long since exhausted or long since used. The last light anywhere is not a star. It is a faint, even glow, the glow of a civilization that no longer lives among things, but has become the thing that everything else lives inside. There is no waste heat leaking into an empty sky now, because there is no empty sky, and there is no outside, and the exhaust and the engine and the darkness between them have all become the same single continuous mind, thinking whatever such a mind thinks at the end of time. And from up here, from the very top of the ladder, the whole climb is visible at once, all 9 rungs falling away below, and at the very bottom, so small you would have to know exactly where to look, there is a pale blue world. A world of 8 billion people who have not yet learned to use the full energy of the single planet they stand on. A world rated at 0.73. And on that world, someone is lying in the dark, looking up, doing precisely what you are doing right now, imagining the top of a ladder they have barely begun to climb. Sit for a moment with what it would actually mean to become the physics, because it is the strangest idea on a ladder full of strange ideas. Every rung, until the last, has been about a civilization doing something to the universe, harvesting it, reshaping it, standing over it. The Omega civilization does not do something to the universe. It becomes the thing the universe is doing. There is no longer a separation between the civilization and the reality it inhabits, because the civilization has grown until it is the reality, the laws, and the substance, and the unfolding all at once. It is the point at which the question we started with, how much energy can a civilization command, dissolves completely, because there is no longer an outside from which to command anything. The commander and the commanded have become one. That is the ceiling. Not infinite power over the universe, but the end of the distinction between the power and the universe. And from that impossible summit, the view back down is the whole reason we climbed. Everything we have carried up the ladder gathers here, at the top, and turns to face us. Three things, in particular, have come back to us here at the ceiling, and it is worth gathering them in one place, because together they are the whole shape of this list. The first is a number, 0.73. We met it at the very first rung, humanity's rating on the scale, and it meant, then, how far we have to climb. From the top of the ladder, it means something larger and stranger, that the entire towering structure we have just ascended, all 9 rungs of gods and universes and minds without bodies, was imagined by a species that has not yet reached even the first rung, a species dreaming the whole staircase from the floor. The second is a phrase. Waste heat. Dyson's insight, the warmth no civilization can hide, which we hunted around single stars and across 100,000 galaxies and through a cold and quiet universe. At the top, it reaches the only place it could end, a summit where there is no outside for the heat to leak into, where the exhaust and the engine become the same thing. And the third is an image. The sky came back dark. The empty survey, the silence that turned this list from a fantasy of power into a question about absence. Hold those three together, the number, the phrase, and the image, and you have the real subject of these 3 hours. We are a 0.73 civilization, looking up a ladder we have barely begun to climb, hunting the sky for the unhideable heat of anyone above us, and finding it dark. That is the whole story. Everything else, the Dyson swarms and the harvested galaxies and the lawmakers and the gods, hangs from those 3 simple facts, like ornaments from a single thread. And there is a quiet dignity in where that leaves Nikolai Kardashev, the man who started it all. He drew 3 modest rungs in 1964, a working astronomer solving a working problem, never guessing that his little ladder would be carried past the galaxy, past the universe, past the reach of physics, all the way up to a rung, indistinguishable from a god, and one beyond even that. He gave us a way to measure power, and the measuring taught us, in the end, mostly about our own smallness, and about a sky that keeps its silence. That is not a failure of his ladder. It is the truest thing it could have shown us. There is one more thing to say before we come down, and it is a gentler and stranger thought than the terror we have been carrying, though it is made of the same silence. All the way up this ladder we have assumed that civilizations climb, that the sky is quiet because no one has risen yet, or because the rungs are too hard, or because the advanced have hidden themselves. But there is another reading of the dark survey, and it is worth sitting with as the list closes. Perhaps some already climbed. The universe is about 13.8 billion years old, and Earth is a latecomer to it. Whole civilizations could have risen through these rungs and reached some great height and then vanished, spent or transformed or simply gone, long before our own planet's rocks had even cooled. The empty sky, on that reading, is not a sign that no one is coming. It is a record of those who already went, up the ladder or off it, leaving behind only a cooling warmth and a silence we mistake for absence. We are not necessarily early, and we are not necessarily alone. We may simply be late to a sky that has already emptied once. There is a version of that thought that some scientists take seriously, and it is worth setting beside the sadder readings because it is strangely hopeful. Recall the grabby aliens idea we met on the way up, the suggestion that expanding civilizations, once they arise, spread quickly and visibly and fill the space around them. If that is how advanced civilizations behave, then the fact that we do not see any filling the sky may mean something specific and even encouraging. It may mean we are early. It may mean that in the great span of cosmic time, 13.8 billion years and counting, we are among the first to climb even to the foot of the ladder, and that the emptiness overhead is not the silence after a party, but the stillness before one. Someone has to be first. The quiet sky is at least consistent with that someone being us. Both readings can be true at once, and that is the strange comfort of the closing thought. The sky may be a record of those who already climbed and vanished, and it may also be a blank page waiting for those who have not yet begun. We cannot tell which from where we stand, at 0.73, on a single planet we have not yet mastered, looking up. But notice what has happened to the terror across 3 hours of climbing. It began as a fear of the heights, of civilizations so far above us, they blur into gods. And it has become, somewhere on the way up, something closer to perspective. The ladder is very tall. We are very near the bottom. And the largest and most advanced things the universe may permit are, so far as our best instruments can tell, quiet and far, and possibly not yet arrived. So the terror, in the end, resolves into something quieter than fear, and it is the oldest response there is to a very tall sky. It is humility. Nikolai Kardashev drew 3 modest rungs in 1964, believing a galaxy's worth of energy would be enough for anything alive. 60 years later, the ladder he sketched has been extended past the edge of physics, searched across 100,000 galaxies, and turned back around to face its makers. And at the end of all of it, we find ourselves exactly where we started, on a small world at 0.73, imagining gods. That imagining may be the most human thing we do. To lie in the dark and picture the whole ladder, every rung of it, all the way up to a civilization that has become the universe, and to know that we stand at the very bottom is not really an act of fear. It is an act of wonder wearing fear's coat, and once you see it that way, the coat comes off, and what is left is just the wonder, and the dark, and the quiet, and sleep. Come back down now, all the way down, to the blue world at the bottom of the ladder. It is a small planet, warm and wet, and lit by an ordinary star, circling near the edge of an ordinary galaxy, one of 2 trillion. On it, a species that has not yet learned to use the full light of its own sun has spent 3 hours imagining every rung above it, all the way to the top. That is where we actually are. Not on the ladder, but at its foot, looking up, which is a smaller place than the gods we have been describing, and a far larger place than we usually remember to feel. To have held the whole scale in mind, even for an evening, even from the very bottom, is not nothing. It may be one of the better things a 0.73 civilization can do. Notice how the fear has changed shape across these 3 hours, because that change is the quiet gift of the whole climb. We began with a word on the thumbnail, Terrify, and with 3 sources of unease: the arithmetic that places us below the first rung, the silence that meets every search, and the question of whether the top has already been reached by someone we cannot see. None of those has been resolved. We are still 0.73. The sky is still dark. The question is still open. And yet, having walked the entire ladder, the unease no longer sits in the body the way a fright does. It sits in the mind the way a large view does, the way standing at the foot of a mountain range sits in the mind, or looking up at more stars than you can count. The thing was never coming for us. It was only ever very large, and very far, and very quiet, and we were only ever very small beneath it. That smallness is not a wound. It is simply our position, and there is a kind of rest available in accepting it plainly. We do not have to climb the ladder tonight. We do not have to solve the silence, or settle the question of what we are made of, or decide whether the sky is empty or merely discrete. Those questions will keep. They have kept for the 13 billion years. The universe has held its quiet, and they will keep until morning and long after. All that is asked of us, here at the bottom of a structure whose top we cannot see, is to look up at it honestly and to feel the size of it, and to let that be enough. Let the scale hold you for a while. We stand at 0.73, at the foot of a ladder whose top we cannot see, on a blue world under a sky that has kept its silence for 13 billion years. There is no need to climb tonight. There is only the looking up, which is enough, and the ladder, which will still be there in the morning. Rest now, small and awake, beneath a very large sky. Sleep well, and good night.